And that way we'll have a second day saved session for you. Oh, there's Eric, just in time. Welcome. Although, who did we lose? The two Brian's Rich. 1, 2, 3, 4, 5. Okay, that's everybody. All right. Eric, I trust you got everything straightened out at your office. I know that can be a issue when the power goes and everything resets. So welcome back. All right, so what we'll talk about a little bit this morning is essentially how we need to approach uh, this idea of modeling terrains, modeling the surfaces, modeling three-dimensional information. And there's several different ways we can look at that. But it really all boils down to we need to know how in the computer we need to represent the edges or points along something at their proper elevation, so that when we're looking straight down on something, it looks like a flat map in plan view. We don't really think much about it. And sometimes, like with a contour map, we have information that conveys that elevation to us, but it still could all just be drawn flat. But in truth, if we're going to model this kind of information, we need to know that elevation information about all of those items, and how best to go about and show them in the computer. And that's where we'll do some work today as we learn to do this. But if you look on page 18 of your training guide, you'll see the little discussion about what goes on with surfaces and contours or terrain model. Gives you a little background about it, some basic. I'm not going to read all that to you. We will talk about some things. But see, they're starting with page 18, and that goes through this discussion about through to page 25. So not very much information at all. I mean, you could write, and people have full college textbooks on this process and about the algorithm behind it called Delaunay's criterion and how that is formed. But the excuse me, the basic gist of all of this is understanding what happens in the triangulation process. We have to triangulate our data, which means to turn it into triangles. And why are we using triangles? To answer that question, it is that 3 points is the minimum information necessary to represent a plane. If you look at this figure on the screen now, if you take the 2 points across the top, well, those 2 points can lie in an infinite number of planes that sort of rotate through that line. But if you also include the point in the lower left, the 110, now you have fixed that portion of that plane that lies between 100 and 110 and 110. So it's level across the 110 line, but drops down to 100, and it's fixed. It cannot rotate. It defines that portion of that surface. And when you start summing up all of those triangles all across, everything's it's a continuous uh, fabric, if you will, where all of these triangles have common edges with other triangles, and considered all together, they form this fabric that stretches across the ground. And so our goal and what we're learning to do is learning how to represent the ground the most efficient and the most accurate way that we can. Because sometimes when we get information, um, we have to either add to it adding break lines and additional points if we know what that information is to sort of help further define the information, or we need to at least be able to look at it and verify that things were done correctly by whoever did the data in the first place. And of course, if it's us, we got to make sure we're doing it correctly. So here's the first idea, and where we'll start talking about break lines and why we use them and what they are and how to think about them. And if you've done much of this stuff at all, you probably know what a break line is. And the classic definition of a break line is, well, these lines lie along places of where there is a break in grade. Well, okay, that's lovely. What does that mean? And if you think about it in terms of, let's say you're doing a cross section of a ditch and you're trying to represent that. So you're, in a spot in the field back in the flat part up at the top, and you've got a point there and say, okay, now you walk toward the ditch and you get at the top of the ditch and you would put a point down there, and then you'd walk down the bank because the grade now has gone from relatively flat up at the top to now it's pointing down rather steeply toward the bottom. And so that point at the top of that ditch, that would be what we call the break line. But it always confused me because I was thinking of the line along which I am walking, and that's not where the break line is. The break line is actually the point at the top of the ditch is on that break line, and it's perpendicular to the direction I'm walking, and it connects up with a point on the top of the ditch further down the line or back behind where I was. And then you put all those things together. So it sort of confused me to think about what break lines are until I then realized what they are. And the answer is that they're simply edges of things out on the ground. For instance, the top line of a ditch, that's an edge in that surface. The back of a curb, the top of a curb, the face of a curb, the edge of pavement, the center line of the road, those all represent edges. Okay, so if it is, and the basic rule is that, hey, if it's an edge out there on the ground, if you can somehow define the arrangement of all that data to say all these things lie along an edge and the elevation changes linearly between points along that line, then that becomes an edge. And then if you've got an edge on the ground in the world, then it needs to be an edge in the computer so that we can model it correctly. And here's why. Because when we're making these triangles, the computer goes through and looks at every point that it finds or every vertex in three-dimensional line work. Anything that has an elevation, anything that's non-zero, it will look at those points. It essentially does this. It sits on each one of those point locations, and then it looks around itself 360 degrees, and it's looking for other points or vertices or something that it can latch onto and draw a straight line between where it's standing and where it's looking. And so what it does, it looks around itself, and when it sees something, and if there's nothing in between where it is and where it sees something, it goes ahead and draws a line between its location and that other target, and making that line become the edge of a triangle. Now, once that line is created, once that triangle is created, and by the way, when I'm talking about these lines, they're not actually drawn, they're just in memory. And so when it creates that edge of that triangle, then it acts as a line that will keep other points from looking across it. That will be a barrier that will keep things from looking across it to see the other side. So in the case of what you're looking at here on the screen, if you consider point with the point with the elevation of 110 down in the lower left corner. As it's looking around, now pretend that there are no lines drawn yet, there's no triangles formed yet, but as it's looking around, it sees these 3 points nearby. So it looks up and it sees that point 100 at elevation 100 in the upper left. So hey, okay, I'm going to draw that line. So it draws that line up there. And then it says, I see one in the upper right at an elevation 110. I'm going to draw that edge. So it draws that edge. And you go, okay, well, I see down there at the lower right, there's a point elevation 100. Let's draw that edge. So it does that. And then it does all, around the full circle and everything else. Well, then it goes to the next point. So let's say it goes to the right, to that lower right point at elevation 100. Now, in terms of what it sees, remember, we've only drawn 3 lines so far. So the point in the lower right, it looks back to the point in the lower left. Well, that line's already done, but it looks up and it can't see that point in the upper left at elevation 100 because a line's been drawn between it. That acts as our break line. So it is completely unaware of it, but it is free it looks up at the upper right point and it sees that with nothing in the way and it draws that line. It's now formed a complete triangle. And by the time it gets up to the other 2 points, then it completes those edges. So what is the physical shape of the ground and what you're looking at here? Remember, these 2 triangles are going to form part of this surface. And if you look at the line that goes between the lower left at 110 to the upper right at 110, well, that line is level across the surface and it's at an elevation of 110. And then it has 2 points that it sees to its left, which is to the upper left, and then off to its right, which is the lower right. It sees these 2 points at elevation 100. So there's a point that's below 110 off on one side. There's a point that's at 100 below 110 off on the other side. So this landform forms what's called a ridge, right? So it's going across this line right here, and it holds at that line. Every one of these lines, it's saying the elevation changes linearly between those points. So 105 is right here in the midpoint, say, on those, but it's 110 level across the ridge, and it falls off to 100 on either side. Well, that's all fine. That's well and good. And let's suppose that's what really happens out there on the ground, and that's fine. We can move ahead. However, if you look at those same 4 points in this scenario, what does this look like? Well, this looks like, all right, here's a point that, say, 100 at the elevation 100, same 4 points. It looks over and sees this one, and there had not been a line already previously drawn here. And so it connects the 100 to the 100, and the 110s are on either side. So this is representing a valley or a ditch that across the bottom, and it's going, perpendicular to the direction that the ridge was running. The same 4 points do that, and there's no way to predict how these triangles are going to form. You just have to, and you either pre-draw the barriers in there yourself, in other words, the break lines, or you roll the dice and take your chances on whether or not it's going to model it correctly. And a lot of people will do what I call some shotgun surveying, is they'll go out there and they'll just start measuring thousands and thousands of points. And you don't need to. You only need to measure the points where things change. So if I'm, modeling if I have a point, let's take for an instance down here on this curb figure that you see. So if I shoot this point down here right where the figure starts, that's my face of curb. Excuse me. Well, I can go down, and as long as that changes consistently or linearly, the same rate of change, all the way down to this other point. Let's say it goes down to point D and I don't even need to shoot point C, then I only need that point there and this point back here. I need 2 points along each one of those edges, and then I need to connect the lines between those points, at elevation that connects all those lines together to serve as break lines. But a lot of people's approach would be, well, I'm going to go out here and I'm going to shoot the back of the curb, the top of the curb, the face of the curb, the edge of the pavement, all here along one. They'll take a little mini cross section and then they'll go, 10 feet away and they'll do the same thing, go 10 feet away and do the same thing, 10 feet away and do the same thing. Now that's all fine, but it's more work than you need to be doing if things aren't changing every 10 feet like that, if they're if it's a linear progressive change. The hope, though, or the thinking is that you've clustered your points close enough together that you're going to get your triangles to form along that cluster instead of jumping to the other locations. And for the most part, that is generally true. The closer a point is to another point, the more likely it is to make a triangle edge, but it's not universally true. It's not a rule. So you have to be careful and you have to know when and where you need to have these break lines. So, and again, I'm not going to read all this stuff to you, just pointing out a couple of things that you want to keep in mind. Right there's your little rule of thumb. Okay. So if it's edge on the ground, you need to make it an edge in the model. And again, with the idea of the curbs, here's a very good example of the right way versus the wrong way. If you can see, if you're not using break lines, if you're only using points, these triangles are allowed to form the way you see here, like EAC can form, GCF can form, FBC can form, and the lines that are solid in that little illustration are legitimate edges of triangles because they do run along those surfaces. But the dashed lines represent things that are not correct. Like this figure does not go linearly from A to E or from C to G or from B to F. It needs to go down and pick up the face of the curve, but it can't because it looked from A as it was sitting on A. It looked over and saw E and goes, oh, hey, there's a point I'm going to make another edge of a triangle because there was nothing in between E and A to keep it from forming. But if you look on the right-hand side, if we have those lines drawn, the three-dimensional lines drawn across that figure along each of those edges. Let's say we got the face of the curb. Well, that keeps point A from looking across that line and seeing point E. But point A can see point C, and it can also see point B. And those edges are absolutely fine. They are legitimate. Point E can see point C, point G, and point F, and that's fine. And when it sees point F, for instance, there's no way that point C can look across the line that was already pre-drawn and see and connect to point G. C cannot connect to G because there's a barrier in the way. And that's what those barriers are these break lines. And so we need to know and understand how they work and when and where we need them. Um, and so, and then how to also evaluate the information that we get to see if it's suitable to model our terrain. So again, as you're going to see, we go over stuff. You have to evaluate this stuff. And the easiest way to do that right here, best tools you've got on the job is your own eyes. You need to look at this stuff and see if it's correct. For instance, this this picture down here, we excuse me, we look at it in our flat 2D representation right in here, and we see, okay, there's an aerial photogrammetry job, and I got a bunch of spot elevations and these little jagged lines, like maybe that's a ditch center line, and these are all little break lines that they've put together. Okay, all done very nicely. Well, I need to put that up into my 3D viewer and make sure it's correct, because I look at it like this and I see, okay, there's those road edges, the driveway edges, the stream center line, and they look like they are indeed at some proper elevation across this three-dimensional landscape. If, however, I take this same original picture here on this page in the plan view, and if I spin it up and look at it in 3D and it looks like this, then that tells me those road edges were drawn down here at 0, and they're not running up and down with elevation. So they're not serving as brake lines. They won't serve as brake lines. They need to have elevation to be able to work as a brake line. Okay, so there's two ways of fixing that. If you get a situation like this and you have to try to model that, you can use some tools in the software to take these two-dimensional lines down here at 0 elevation and drape them across the things it finds up here in the three-dimensional side, so that then it lifts them up to what you're seeing here. And then they can serve as brake lines. Now that's okay. It's not necessarily the most accurate, because the only place where it can pick up information is where it crosses over one of these other lines to be able to drape across those things. And if there's nothing there for it to drape across, you might get some weird behavior. It just the best situation is that those are created at 3 dimensions, at the time that they gathered the data, whether it was in the field on the field survey or whether it was through aerial photogrammetry or any type of work. For instance, now we consider, where we get this data, and we talk about compiling break lines and stuff like that. And all the latest rage is to use a drone, go up and start doing our drone mapping, and we're using LiDAR point clouds, and that's all right. And most, or not, I don't want to say most, but some people will consider that drone data, all that LiDAR, that massive point clouds, they'll consider this, oh, well, that's just billions and billions of points, and I'll go ahead and make my surface out of that, and that's all I need. But you still need to put break lines in the data, even from point clouds. And most of uh, the compilation software has the ability to do that. And it still needs to be done. Otherwise, you're still going to get little clips. But usually, because all the points are so close together, it sort of becomes a sort of a toss up on it. So you don't really need to worry about it. But bottom line is we need that stuff at elevation so that we can model things correctly. Okay. So now we've got another situation that you can run into, and this particular image is right up here in this upper corner. If you're seeing this little sort of knockout area right here, and you see the driveway coming into the road. Okay, so that is what this is. These orange lines coming down vertically, that's the edges of the driveway, and the black lines horizontally, that's the road. And all of those other little trying to get my cursor back here. So then all of these other little sort of random seeming black lines, those are those brake lines that were compiled. But see, they were compiled out here and stopped all along this edge down here, and then it turned a corner and went out this way. But what happens in here? What is actually being created in between in this gapped area? And it's forming triangles in there. And the reason why is because when the computer sits on a point, say down here in the far lower right on that point, it starts looking around itself to connect to. And when it does that, then it It might look around and see this point right here. Okay, I'm going to draw that edge. Looks over and sees the end of this line. He goes, okay, I'm going to draw that edge. Sees the end of that line. Okay, I'll draw that edge. Sees the end of the road line. He goes, I'll draw that edge. But it still is able to look way up here and see the end of that line. So it makes that edge. And it looks way up here and sees the edge of that line, makes that edge, and then another one as well. So it forms triangles out here in this part of the model that we don't really know anything about. Okay, we don't know that the ground goes from this edge up to this edge along these long skinny triangles. That's just fill-in work that is you know, it's, I want to say illegitimate. It is illegitimate data. It's information that we don't really know because we don't know. There could be a big hole in the ground. There could be a big mountain on the ground there. We just don't know what's going on. So we need a way to keep that from happening. Now, if you think about it, this kind of condition only happens when the mass of our data that we are modeling has the overall shape of that data. If it has a concavity, if it cuts into things, looks like a little, you know, makes an inward jutting situation, that's where those illegitimate triangles can form. Because if it pushes out instead of in, then those edges will form their natural break lines anyway. But bottom line is we need also, when we're modeling, to put a bounding limit on our data. And that line can be two-dimensional. If we, in part of our modeling, we can tell it, hey, use this line as a boundary. So it can be two-dimensional or three-dimensional, either one, doesn't matter. Because we're going to pre-select it when we go to model our ground and say, hey, this is what's called an inclusion boundary. And just like an inclusion boundary, we can also have something, if we look over here at these other examples, like this little inset, this concavity up here in the upper left, that's where we would have this boundary wrap around the corner here and come down the edges so that these points over here can't look up here and start making triangles. We make that an inclusion boundary as we draw a little polyline around everything and say, go to the inside. Likewise, or not likewise, I would say a corollary to is if you look over at the data that got surveyed, in this case, photogrammetric data, you see some building outlines. Well, we don't know anything about the ground underneath the building. All we can see is the building. And so we can draw the building outline and say that is an exclusion polyline. Okay, so we can say that. Some people don't bother with that. They'll just let those edges, because the buildings themselves will have typically a finished floor elevation, or which would be sort of an illegitimate use that you need the line around the outside wall of the building. You need that to follow the elevations of the ground around the elevations around the outside of the building. So if that building is partially sunk in one corner below the ground, or if it's raised up on a higher part of the foundation in another corner, you need to know where the ground lies up against it to be able to use that. You don't want to just use the finished floor elevation, but sometimes people will do that. And they'll just let the surface form across the, basically across the floor of that building. Okay, just put a flat spot in the surface, whereas technically it needs to be cut out of the surface. It needs to be undefined in that spot. And so that's what we're going to talk about too as we do this. We're going to build inclusion polylines. So everything inside this polyline is going to be considered and modeled, as well as exclusion polylines. So everything within these closed areas is going to be discarded. Okay, so we're going to learn some techniques about that, or how to how to let the computer show it for us. as well. Okay. And a lot of that is going to be really highly dependent on us learning to use this three-dimensional viewer. And once you do, and it doesn't take long, it just becomes second nature to you, and it's one of the most uh, useful tools to be able to check something very quickly, get in, get out, model everything. So, um, and I know I've sometimes tried to model some things, and I'll set it up, I'll build my surface, I'll look it all up, I'll look at the data, I'll look at, and go, oh, well, I see a problem. So I exit the viewer, go back and fix it and rerun the model. And I'll do that 15 or 20 times sometimes just until I'm satisfied that everything looks the way it needs to look. Nothing wrong with that. And these are some tools that are going to make it helpful for us. Okay. And so what we'll do is start looking at our data. And here is on page 25, you're going to see this, this exercise of adding break lines. Now we're going to open up this file and start looking at it. And we'll learn a few of these other tools along the way as we go through it. Now, as you see the steps, you know, the numbered steps in there, you could certainly follow those, and I'll leave that for you to do on your own at some time. But what we're going to do in the class, I'm not going to keep jumping back and referring to these and just regurgitating those steps, but you want to see basically all of what is in here we're going to be talking about as we cover this information. And we go through that, and then along the way, how do we evaluate those surfaces using the viewers, looking at that, looking at a quick profile view, that kind of stuff. And then we're going to be able to wrap up our total workflow. Okay. So let's get some things started here. Let's choose to open a file, and the file we are going to open is going to be from our data set directory, which in this case, I am in that 2024-07-11 fundamentals class. And inside that is that data sets for fundamentals. Inside of that is this sample from T3 Global. T3 Global is an aerial mapping company here in the Pittsburgh area, in Bridgeville. And they have provided this information and allow us to teach with it. So it says one or more shape files are missing. What do you want to do? Just ignore the missing files and continue. Likely a potential font or something that has gone away. Now, let's see, Frank, I think it might be you. Let me look at my notes here. No, Brian Mayfield. Maybe you too, Frank. I'm not sure where you're from, Frank. You guys in Southern Illinois won't have any meaning for you, but at least Brian Mayfield, you're going to recognize where this site is, okay, when we get done with what we're talking about here. As long as you travel within Pennsylvania, east to west and west to east from time to time, you'll recognize this area. So what we're going to do is figure out, first of all, what we have. When we receive this file from an aerial mapping company that's saying we're the engineers, we have to design, say, a little parking area or something on this ground, or we're doing some grading in this site. How do we look at what we have? How do we see what's there and start to learn some information about this ground? Well, there's a couple of ways we can zoom in and look at this ice, and I can see, well, what looks like contour lines and labels. That's all well and good. And if I now in AutoCAD, I can sort of hover on something and get a little bit of information up. And that's like, that tells me the layer. It's called V topo major. And then there's one called V topo minor. Tells me what it is. And I say, okay, well, that makes sense. I'll look at the text label, which is on V topo major ident. So you get an idea, you can get a sense of these little quick properties, or you can select it and look over into properties and you can see things like the layer names. And even at that point, you can see the elevation, 1338. You can assume that this one is 1335, but you don't know for sure until you look at it and you see that, okay, yes, indeed, it is at 1335. So you would normally take, a lot of this stuff on faith. So, but that's all part of that process. But it can also get very tedious if you're trying to check out elevations and layer names and things like that. So there's a couple of tools that is going to be helpful as you start to look through your drawing, as you're just walking around and sifting through the data at first. And here's the way to sort of remember this and how to use it and what to think about going to get in terms of the tools you need is you've got a bunch of things in your drawing. And the only condition, and it's what we call a dichotomy. It's only one of two things that can be possible in your situation when you are inside of a drawing. And one is that you either have something drawn in your drawing or you don't have something drawn in your drawing. So if you don't have something drawn in your drawing that you need, then what kind of what menus would you might start to think about looking for tools under? If you need to create something, you need to draw something, what menu would you use? Maybe the draw menu would be where I would start to look for things. Okay. And so there's where you're going to do most of your creation. You're going to draw 2D polylines, 3D polylines, all of the text, all of the different things to help you create things in a drawing that you need. Okay. That's one area. That's where and that's what we call this class fundamentals. These are the standard fundamental tools, and they're more on a CAD level than they are on a Carlson level. But there are other things. Let's say we had an alignment. If you remember our alignment yesterday, we drew the alignment file and had it station the alignment and show us the PCs and PTs and all of that. So that's a little more complex. And that's usually, those kind of tools are usually on these other complex parts of the menu structure. Remember the first 7, file, edit, view, draw, inquiry, settings, and points. Those are all common to every Carlson module that you have, whether you're using Hydro or if you're using GPS or GIS, rather, not GPS, but the GIS module or the construction module or civil or survey, it doesn't matter. Every one of those modules has file, edit, view, draw, inquiry, settings, and points. And then if you're in a particular module, in this case, I'm in the survey module, I have a survey menu. The civil module does not have a civil menu, but it starts off with the 3D data menu. They all sometimes have overlap, like the survey has a surface menu, civil has a surface menu, hydro has a surface menu, and so does construction, various other places that need to do work with surfaces. Some of these, like for instance, the civil tools on the surface menu have more commands than this one because it's got something like in civil, you come down here, we have this in survey called design pad template, where we can actually create these pad structures and cut them into some other examples. But civil has a companion command to that called design pad edit. Okay, so it's taking the tool that allows you to create that design pad, and then it's got tools that allow you to make changes to it and have it dynamically update. Uh, Survey does not have that. You would just have to go back and build it from the ground up again. Okay, so um, there's all kinds of things like that. The survey has some profile tools, and they're all sort of appended on down here at the tail end of the surface menu. Contrast that with civil, and civil has its own complete profile menu because it's more likely a tool that you'll be using to create roads and pipe profiles and things like that. And it's more of a design type tool that we would use with the civil type workflow. Okay, so you're going to see, some overlap. I'm going to switch back to survey now because that's what most of us are looking at. But we're going to consider that, let's say, like we had that center line with the stationing and we needed to draw that, we wouldn't look on the draw menu to try to find, how do I draw a center line? In that case, I'm going to look under a center line menu. And so a lot of these have they're structured by the design portion at the top or the creation portion at the top. And then they have some draw tools or some reporting tools sort of in the middle. And then you got some utility type things at the bottom. So here is a draw centerline file. So if the file is already existing, then this is going to put you into that type of location. If we look at our surface menu and we come down into our profile section, well, there is our draw profile. There is also a draw surface, and that lets you draw a couple of aspects of a surface file. You can actually draw the triangles if you want them in your drawing. No real need to do so, but you can do it if you need it. And sometimes it's helpful. You can even, and this is more helpful most of the time, you can draw the boundary of that surface. So you can see if you're overlapping with another surface that you're working with. The other thing that you think about in terms of drawing a representation of your surface are drawing the contours. Well, that's not under this, but you do see that there are some tools up here in the upper part. So I can contour from a tin file. Now remember, all that's doing is creating the drawn contours. They're just polylines, and it's putting them into your drawing by reading all of those triangles in that tin file, and it's putting them into the drawing for you. And then once they're there, you've got some utilities. You can do some things like, put the elevation labels on them, or you can move the label along the contour. You can flip them, turn them around if they're upside down. You can do this edit contours, which I'm going to, I'll tell you right now, when you do that, and a lot of people like to do that, let's say they look at, say a situation down, let me see right in here and see this contour line doesn't look real super smooth. And you'll see, people will try to knock out these little angle points. Maybe they'll run a line across here, make it look smooth, and they'll make that nice and pretty. Well, that's okay. You've made a pretty polyline. But the actual model that you've created, let's say you've done something that looks like this. Uh, all right, so you've gone and edited those contours, and you've basically used this orange thing to make it nice and smooth, and you cut out these jagged parts and you hook them back together. Well, that's fine. But what is actually going on elevation wise right in here? If you, let's see, what is that? 1315. If you alter this line to follow the orange location, then it's going to tell you that right here on the ground, that elevation is 1315. And that up here, this elevation is, let's see what this one is. It's 1360, so going uphill this way. So in your model, or when you change this contour line to say that's 1315 and it's 1316 up here, then you're saying, well, on the ground, right in here is going to be 1315.2 or whatever. You want to say it's slightly higher than 1315 on its way up to 1316. But in reality, if this is a contour that comes out of the actual modeling process, that's where 1315 is back here. And back in here where this new location is might be 1314.8 on the ground. So, be careful with some of those tools. Some of them are just cosmetic and it's not hard to think about and remember that kind of stuff. You just got to ask yourself, well, if I use a command like edit my contours and I do that to sort of, make them look smoother, or if I've got a little loop in them or something that I'm going to try, make sure that you're not illegitimately changing something, because that surface is still going to be reflective of what made the contour in the first place. So you need to fix whatever caused the problem you're trying to create or trying to correct. You need to fix that problem before you move ahead and go back and rebuild the surface. So anyway, back to this idea of this dichotomy, this sort of decision tree. You've got one of two things. You either have something in the drawing or you don't. If you need something that you don't have, you need to start by, looking for draw tools, or look for things like draw centerline file or contour from the tins. That's going to generate the contours, or draw the surface, triangles of the boundaries, or draw the profile. Those are things that are going to read those external data files and create the drawn elements from those. If it's not stored in those external files, that's where you're likely going to see these kind of tools. All right. Now, the other condition is, all right, something does exist in your drawing, so you don't need to draw it, but you can do one of two things to it. You can leave it alone, or you can change it. And if you change it, those are some modifications. Those are edits. All right. So what menu would I look for to make those changes? I would look of a lot of things over here under my edit menu. And if I look for, let's say, if I wanted to erase, well, no, we know enough about our CAD system. We can just select a bunch of stuff and hit the delete key that erases it. But what if you only wanted to erase a part of something? What if you wanted to, let's do this as a quick little exercise and we'll undo it. But let's go and let's draw. Let's go to the draw menu. Let's draw a 2D polyline and just hit OK. And I want you to draw what's essentially some kind of, arbitrary shape here. And then I'm going to type C to close. All right, so what I have here, I'll give you some weight so you can see it. All right. So just draw you something like that. All right, now this is obviously not not a stupendous kind of thing that you would do all the time. But let's say we have something like that. Okay. And let's say I wanted to, or if I needed to, for whatever reason, I needed to erase some things, but only the stuff on the inside there. Well, what happens? If I go to, if I wanted to erase this contour line, but only on the inside, well, I need to break that line where it crosses that edge, right? And break it up here where it crosses that edge, and then erase the part left on the inside, but leave the part left on the outside, or vice versa. If I'm if I'm erasing stuff on the outside, I want to keep the stuff on the inside. So it's not a trivial task with just erasing, right? But if you look, and here's where Carlson has added a lot of these types of tools. You go to the edit menu, erase, and you see this erase by closed polyline, okay? Now, let's say if we're going to erase on the inside of that, so I'm going to choose that command, erase by closed polyline. I'm going to read my prompt. It says select the perimeter polyline. Now, this has to be a closed polyline. So I'm going to select that line, and then I'm going to check on all of the things that I want to consider getting rid of. I just leave them all checked here. And then whether you're going to erase inside or outside, and this other prompt for exclusion, because you can have a little boundary on the inside of here that you want to keep everything on the inside of it, erase everything on the outside of it, but then stop at the edges. If you follow what I mean, it sort of makes like an island of your data. So let's erase on the inside, and we'll say okay, and boom, there it is. Okay. Now there's a couple of little stragglers. There's this, for instance, this piece of text. And if you look, if I select that, the insertion point of that text lies on the outside of that boundary. So that's why it kept the text, because it won't slice the text like right through a letter. It's a text is kept intact. If the insertion point is inside the boundary, it goes away. If it's outside, it stays. Now we also have one item down here, and this is a standard old polyline, and that should have been clipped. It didn't. So you would, at that point need to just select that and say trim and get that off, or say TR, enter, and get rid of that edges there. Okay. So, and that's sort of what, I think of that tool as like a cookie cutter. All right. Now I'm going to undo until I'm back, all the way back to where I had not erased it. And likewise, if I repeat that command, edit, erase by closed polyline, I select that polyline. This time I'm going to erase on the outside, and I'll say okay. And it's going to do the very same thing. And you see there's a piece of text that is on the inside, even though part of it was outside, it kept the entire thing. Now, the reason I wanted to show you that, and I'll undo that till I'm back, is to contrast that with the other command that looks similar, erase outside. Okay, so if you're doing something and you need to do what we just did, where you need to use the shape to clip and trim things that are outside, then that would still be erased by closed polyline. But there's another command called erase outside, and it's not the same. Erase outside is simply going to mean if I choose that command, notice I don't pick a polyline. It says pick the first corner of a window to erase outside of. So if I pick this corner and say go up to here, now watch what happens. So I showed that, and it erased everything on the outside, kept what's on the inside. But did you see there were things in here that are gone now? And the reason for that is when I had this erase outside and I gave it that window, let me undo that to come back to it. When I gave it that window, if anything, and here are these contours that are back, but you see part of it lies outside of that window that I picked. And as long as that's true, if any part of anything is outside of that window, it erases the entire thing. Okay. It doesn't clip, it just erases everything outside that. So a good use of that tool is here. In fact, I'm going to go here and say delete this. There's a good use for that erase outside, because sometimes if you'll get a situation like this, and if you'll do a zoom extents, remember that's double clicking the wheel. And what will happen is you'll see that, your data is way up there and there's something somewhere outside and you can't find it. You don't know where that is to get rid of it, and you're trying to make it happen. So what's a good use for that tool is you get zoomed in to where you happen to be and what you're looking at. and this is what you're working on, and then you would run that command, edit, erase outside, and you just make sure you got big enough window to where everything is included that you want to keep. And so I would just do something like that. And now it has taken everything that even partially lies outside of that window and it has erased it. Okay. So another couple of clever tools. And let me show you something about this tool kind of concept. If we are looking at these tools and where they are in your menu or in your training guide, in the command reference section, this is after the last of the exercises, you're going to see all the commands by menu. So there's your file menu, and you're going to see things like, new, open, close. Those are your typical kind of Windows kind of stuff. You've got the save as, import, export, etc. So, and then here's a command, and you see that one is listed as it's red in color and bold-faced. That means that it's generally got some good power to it. You might want to consider taking a look at some of the things it can do for you. And then we've got other things like here's your drawing utilities, running audit. Again, it's a standard CAD thing, but these are where those tools are positioned. But if you look at this edit menu, here's one of the things that from this point forward, after the file menu, well, this edit menu, and it's pretty extensive, and it contains standard CAD tools like move, copy, trim, and rotate, all of those standard modify tools you'll find on the edit menu. But you'll also find some of these enhanced tools like that erase by close polyline. Another one that I use all the time is erase by layer. And there you see it's in red. And so what happens from this point forward on the menus is that if it's a CAD tool, you won't see it in this list. If it is a Carlson command, you're going to see it. So, and these are the ones, and it's just the ones that you see that are red is just something that from my experience have been very helpful commands. Plenty of them might be helpful to you, and they never were to me, but they might be, for you, like this copy to layer might be something you use all the time. Okay, but maybe it's something that maybe I don't use a lot of. Okay. So as you're working through things, keep your manual handy or even if it's just the PDF, and you can look that up and learn what those are. And we're going to use them from time to time and see, what effects they're going to have on our work. But let's get back to this idea of this dichotomy of our drawing. We either have something in the drawing or we don't. If we don't and we need it, we draw it, or we go go to the specialized menus and look for things that will draw from the information in these external files. Or if we do have something, then we either leave it alone or we can make changes to it. If we make changes to it, we can find out a lot of tools on the edit menu. And here's what a lot of them do. And I'll talk you through a couple of these. I won't actually do them, but I can erase by layer. So it lets me pick a representative on one or more layers, and it erases that entire layer. We just did an example of closed polyline and outside. Now, these erase, this temporary erase, I'm going to tell you right now, it's a dangerous tool because you might think it's handy to get them out of the way. It's more appropriate to just turn those things off than it is to temporarily erase them, because if you forget to restore them and you save your file and exit, they're gone. Okay, so temporary erase, I don't know why they made that a command, but some customer somewhere said, hey, wouldn't it be cool if, and so they did that. So these are some different things. Now, And here's erase uh, by network, and that's going to ask me to select a network entity. Well, I don't have, and that would be like a pipe. I think that's a new command. You won't see that in your manual. Um, I'm not even sure exactly. Let's see that erase. Yeah, they don't even have it documented. So they've got temporary erase, but they don't have erase by network shown here. All right. So I don't even know what that command does. I don't know that they know what that command does, but there it is. Those are the things to try and keep looking at things like that. Look at your copy command. You got a standard copy. That's your standard AutoCAD copy. Or you can copy something to a different layer, or you can copy a section of some line work, not the entire line work, but just a part of it to uh, to a new entity. So these are the changes that you can make that you want to see on the edit menu. You've got all of your standard CAD modification tools, which are typically, I've got mine over here in this modify toolbar that you see vertically on the right. That's my CAD modify tools. Okay, and I use them a lot. But here's the other thing. What we're getting ready to talk about in another tool that's very useful is, okay, let's say you've got things in your drawing and you can either leave them alone or make changes, but how do you know whether you need to make changes to something? Well, you need to find out some more information about it. And what do we typically do is either we'll hover over something and let AutoCAD, if it decides it wants to do it, pop up the little quick properties, and I'm not seeing it working right now. All right, there's a little quick property. Shows me the layer and such. I wonder why it wouldn't do it for that one. It's not doing it for these white lines. Okay, well, that's an AutoCAD weirdness. It doesn't work. So, but Carlson has another set of tools and a complete menu, because if you don't know if you're trying to figure out whether something needs to be changed or not, we need to ask some questions. So what we normally do is we'll select something and we'll look at its properties. All right, I see that that's a 3D polyline. It's on this layer. It has this color. It's on this line type, and it might have these, uh, coordinate locations. I might select a piece of text and, all those kind of different things. We do that quite a lot. But instead of having to select something and look and see what layer it's on, then press escape to deselect it and select something else and see what you think about that, we have an inquiry menu that has a couple of automated tools in here. And you can see list is your standard CAD list. Point ID just reports the coordinates. But I have a layer inspector and a drawing inspector, and those are going to be some really cool things that I can do. So let's look at the layer inspector first. So if I select that, I'm going to get up here on the bottom. I see this little split screen, and I've got a list of my layers over here on the left. Now, unfortunately, you can't resize all this. It would be nice if you could. It's a little bit awkward, but and then over to the right of that, I can see a thing that tells me how many entities are on the layer that I've selected. So if I look at, there's lot lines, there's building ID. All right, under building ident, I've got 2 entities. And it tells you what your current layer is. You can also do this. And again, this, if you click up into plan view part, you can still do your panning and zooming. But as part of this inspector, you can say, let's isolate the things on the layer. But also, if you do something like that, you want to make sure that you restore the view on exit. So if we go back out, it's going to take care of, showing everything that you should be showing. So now if I click on building outline, well, I see all the building outlines. You can also do zoom, so that if I did, all right, there's one thing on this thing called V-ditch existing water. There's V-ditch power poles. And so it's zooming in and out. If I go back to that building ident, there's the 2 words. So zooming, I'm going to scroll down here at the bottom and look at my break lines so I can get back out. So zooming is not necessarily someone so but excuse me, you can do more than one. So if I select my building ident, and if I also want to see the building outlines, well, I can just control click and see more than one. Say scroll down here and let's do a control click on the parking outline and the V road curb. So it sort of works the way AutoCAD's layer walk works, except it lets you, zoom once you're in the tool. You can zoom in and out and pan and do different things. Plus, you can also get some information like how many entities are on the selected layers. You can choose to erase those entities. And then if you have an empty layer, such as lot lines has 0 layers, I've got this purge button so I can get rid of empty layers. All of this stuff all within the same tool set, okay? So that's another nice little tool if I'm interested in layer membership. So I'll exit that. And that's the restore view on exit has put things back the way they were. But here's the other one on the inquiry menu again, and that was the layer inspector. Well, let's look at the drawing inspector on or off. Now, this is a tool that allows you to just hover the mouse over top of things, and you're going to get reports in this little pop-up tool of what those things are. So notice down here on my command line, when I ran the tool, it said that the inspector is on. Right click to activate the pop-up menu. Okay, so now I'm going to right click the mouse and I can see what is now active. So I'm going to say, well, let's say I want to see the elevation and I want to see the layer name. Okay, so I'm going to right click and then left click on the thing I want to see. Now that's going to make the menu go away. You bring it back with another right click. And I'm also going to display my polyline data, enable highlighting, so it will just do like a pre-selection highlight. And this enable tag display is what pops the little window up. It's almost always best to use that. Show data on the status bar. Well, that tries to print everything down here on the bottom line. Sometimes that's not very successful. So, but also this command can be running and it can stay running while you go off and do other things. Like you could go back and edit, erase by close polyline. You can do all those different things, but and this is still running. So now I'm looking at elevations and layer names and all of that. So if I'm hovering here, I see that that has a layer of V-topo break line, and the elevation of right where I am positioned is 1318.714. I move the mouse. Now I'm not clicking anything. I'm just hovering. So if I move the mouse, you can see the elevation changing on that 3D polyline. And on that particular one, I am going to go ahead and select it so you can see the vertices. But you see in this particular segment, look at the window and it tells me the horizontal distance and the slope distance, the 21.189, 21.194, and where it starts and ends elevation wise. Okay. And then you see a slope expressed as a percentage and as a ratio. And that is the slope of just that one segment. Okay, so you can see the Z start and end of that segment. And if I come down here to this segment, it's got a different Z start and end, and it's just of that segment, same as the slope. So the slope is, and the slope and the Z start and end values stay constant within that segment, but if I'm over another segment, they're going to change. It gives you a total horizontal distance and a current distance, meaning the total distance is the distance from from the start of the unit. So there's my current distance is 1.7, 2.9, 3 point blah, blah, blah. And I get up to here. And so that's the accumulated distance from the beginning of that entity. And you can see up here, I'm getting closer and closer to my total distance of 97.954. Okay. But that tells me that. And then finally, it tells me whether it's open or closed. And that one is the open. So a lot of times, um, we'll have this, and maybe all I want to see is the layer and the elevation. I don't need all of this polyline data, and I'm just going to, okay, that's good. That's elevation 1304, that's 1305, and I'm going to use that. Let's see, there's 1310. Yep, that's what the label says. So you can use that to sort of help verify your way around through a drawing, okay? Because sometimes you'll get things that are looking fine in plan view. And now I'm going to right click at this point and say, turn off the drawing inspector. You can do it that way, or you can go back to inquiry and do drawing inspector on and off again. But sometimes you can have things that look fine in plan view, but maybe they're drawn at the wrong elevation. Even though you see this, say 1315, maybe somebody who put this together put that elevation on, let's say 11,315. So they accidentally hit the one twice. Okay. You follow what I'm saying? That can happen. And I've seen data sets like that where certain things were drawn at the wrong elevation. Nobody caught it, and they didn't bother to be able to see, what this stuff looked like. So we need to take a really kind of a fine-tooth comb through things to make sure we've got what we need when we're trying to model this data. Now, there's one other thing, and we've already seen, doing things like this, where I can sort of see, yeah, I've got some stuff down here and if I select that and I look at its properties and I see it has an elevation of 0. So I make an assumption that, things are probably all on that 0 elevation. Now, that could be wrong, right or wrong. It could be that I've got something that's that's sitting at 0.5 elevation, and that could cause a real problem if I'm going to model this. If these are not all exactly 0, and if I select it as part of my modeled set, it might pull my surface down. It have a giant leg down here to that something that's way down below it, but it's non-zero. It'll be what we call, you would generate a well or a table leg. Um, the opposite direction, if there's something that's stuck way up here and it's included, you're going to get those witches hats. You'll see that when you generate your surface as um, as a tightly packed ring of contours that comes up to a spike if there's a point that's up there and doing. So those are ways that you can help evaluate this stuff. You can look at all of this and see, well, that looks okay. It looks like things are in place, right? Go back to my top view here. And there are some other ways as well. Maybe we've got something, I looked at that, but I wasn't able to see necessarily whether everything was down at 0 exactly. So if another great tool, you look at the file menu, and this is something that you might want to consider doing with every new file that comes in from outside the organization or outside of even within the organization, but it's something that you didn't put together and you're not sure of the history of it, you can choose this drawing cleanup. So let's go ahead and run that and look at all of the different things that this tool can do. Now, every one of these tools on here are available separately in other tools, other commands. But this puts everything together that might be some common things that you would be normally considered or normally considered that you normally would consider needing to do to some of your data. Um, and you can see you might have a huge data file that you got to clean out. There is a defaults button, and this is what the programmers decided that you probably need. You got a clear button to clear everything out. Okay, now we're not going to go through all of these different things, but you can see what it will do. You can do that, remove arcs. Okay, and remember there's that offset cutoff. If you've got some polylines that have real tight vertices and they're just way too dense, you can use that to thin them out a little. So there's a number of different helpful things that you can do. But one of the things that I use this command for a lot is to verify and change if I need the elevations in the data set. Okay. Because one of the things, and what I do is I clear everything. And then the one that I want to look at is this bottom one that says set elevations outside a particular range to 0. So I would be able to type in the minimum and maximum value to verify. Okay. And so when I do that, but before I run the command, I want to hit this scan drawing button over here to the right. If I scan the drawing, it's going to look at the drawing and it's going to come back and fill in the minimum and maximum fields down below. So it's saying, all right, of all your data, now it ignores 0, by the way, but of all your data, you've got a minimum elevation of 1280, you've got a maximum of 1347. What do you want to do? We said, well, that's fine. That seems about reasonable. But if I had something like, I'm going to cancel this right now, and I'm going to select uh, I'll select these and give them an elevation of, say, -1. And then I'm going to select these. And give them an elevation of just 1. Okay. Now, I can't tell that that's happened here. I could if I, did something like that. I go, ooh, I got some things down there I need to fix. But I can, even before I get to that, I would run that command, drawing cleanup, and I would clear, set my last one, and scan the drawing. Now, oh, well, I found something down at -1. I don't know what it is right yet, and I know that I'm up around 1350 in my elevation. Let's say, I'll say, well, okay, to be safe, I'm going to say, anything lower than 1,000, and say, or if there's anything, I want to keep everything at its assigned elevation if it's between, say, 1,000 and 1,500. All right. And then I'm going to say, okay. And it says set 7 entities outside of that range to 0. Now, what that means is it did not raise them up to where they need to be. See, there they are. But now there's, instead of there being -1, you see it's 0. So it gives me a way of taking some data, some stray data that might be at the wrong elevation, and marking it by putting it at 0. So it takes it out of my consideration when I'm building surfaces. Okay. So now here's a little trick. Once you've done something like that, those are the things that got placed down at 0 that need to go back. I'm going to go up at properties. I select everything and I change the color to be red instead of by layer. And the reason I did that is because, oh, now I can see which ones I want to change without having to spin that around. And so what I need to do is, well, that needs to connect to that, or it needs to be the same elevation. Right now it doesn't connect. So I look at that elevation and it's 1310. then that means that that one needs to be 1310. Okay, so I would then fix that as 1310, just from the properties. Okay. And now that I fixed it, I'm going to change its color from red back to by layer. All right, so that one's now where it needs to be. This one's going to be 1311, it looks like. Okay, and there that is. Now there's a couple of things that you can do with this on your surface menu contour utilities is you can assign these elevations, except apparently not in the not in the survey module. If you were in civil under surface, you can my contour. You can let's see here. Maybe they've moved. Yes, they don't want to digitize it, but where the heck did they move that? Oh, I know, it's not under the surface menu, it's in the 3D data, sorry. So you can assign these contour elevations by either multiple in series or from the labels, so it will read the labels that it might go around, or a single elevation for a group of contours, so different things there. Multiple in series, for instance, if I say that, then I'm going to say, well, my interval is going to be 1 foot. Majors are 5. Layers, I'm just going to clean out because I don't want to change their layers. Color, I'll set them to by layer. And that should work. I'll say okay. And so now it wants to know a first point. So I'm going to draw a crossing line. So I'm going to go from that line up to there. Okay, so 1310. Now it asks for a beginning elevation, 1310. Do I want to go up or down? In this case, I'm going to go up. Okay, so it updated those. Oh, I see what happened. Let's undo. And let's see, first what this layer is V topo major. That one's V topo minor. Okay, now as for settings, 1 to 5, V topo major or minor, and V topo major. So I'm going to go from there to say there, and it will be 1310 going up. All right, so now I'll go back and turn on my, say, drawing inspector, look at my labels, and I'm at, oh, look at there, 11,318. Okay, so apparently I typed in something wrong. Another reason to go back and verify. All right, so let's fix that again. So we'll say, repeat. Settings, 1, 5, blah, 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 say okay. So I'm going to start here and go to there. And this time I'm going to start at 1310 instead of 11310, going up. I'll put my inspector back on. Now look, there's 13, 19, 18, 17, 16, 15, 14, 13. Okay, so all these kind of things, nice ways to identify and verify our data. Same thing as if I'm going to go turn that off. Another way to verify this data is we have a tool on their surface menu, even though we haven't built a surface yet, down at the bottom called Quick Profile. So if we want to do a quick profile, we're going to take our source, instead of being a surface file, we're going to say screen entities. We'll say okay, and it wants us to pick a starting point or use a centerline file or a previously drawn polyline. Well, I'm just going to click here and drag across to there. And I can keep going, but once I'm done, I'll hit enter. And that gives me a little way of looking at something here. So if I look at, um, down here, it's reading off over there on the right-hand side. I can read the slope, the station, the elevation. I can give it a vertical exaggeration of 1 or 2 or 5 or fit, so whatever it happens to be or needs to be. And so if I go across here, and I can click up in the top here and say position things, and then click back in the bottom. But right in here, you see that where the crosshairs are in the bottom view, and it shows flat across the bottom. Well, that's an indication of up there at the top that I'm going across a flat, something that has the same elevation on either side. Well, that's okay. All right. Now, if I have a situation like this, let's say this one elevation, instead of 1300, let's say it was a similar thing that I did before. Let's make that 11300. Okay. And now if I go back and do another quick profile by screen entities, let's just go across like this. We'll stop and oh, look at that, right? So there's something right in there. And if I look and see, it's that one right there. Okay, so that reading the wrong elevation. Now I have to get out of this command to be able to make the change. So if I exit that, let me make sure I mark which one it is. All right, it's that one right there. So if I get out of that and then select that polyline and change its elevation, now I'm back in good spots. So, but here's the nice thing about this tool. And it's really nice when you're looking at surface files instead of just drawn entities. But there, and you see where the where the marker is as to, what you're looking at. And if you have a surface file, which we're not looking at here, I don't know why it doesn't do this, but if we were looking at a surface file instead of screen entities, and I'm going to use one from a previous class here, and I'm going to say go from here to here. All right, so there it's reading the actual surface file, and you can see going across right in here, going across that bottom of that pond is no longer dead flat because there was a little, say, let's come up here and think about where we're looking at. See, there's some spot elevations in there that help to pull that down a little bit, right? So, but now here's the nice thing about this tool is if I'm looking at that, and if I'm looking at a surface file, I've got this adjust alignment button, and I can pick this up. If I choose that, And if I pick nearer one of the ends, I don't have to snap. If I just pick nearer one of the ends of that line, it will anchor the other end. If I pick nearer to the midpoint, which is apparently what I did, then it moves the line parallel to where it is in the same length, and it lets it go and cut other areas. So it's looking at this in real time. It's cutting that surface in real time, and I can take a look at it like that, and then click it down and move to a different space. If I choose to, I need to make it longer, shorter, whatever, and I click and put it down in a new location, then it's going to reposition that. I can go back and adjust the alignment again. So I can do that, adjust the alignment, and maybe change the way I'm looking at stuff. Again, adjust alignment, sort of use it to drag around and make sure that everything has been modeled the way you expect it to be. You don't have any highs and lows and weird things going on, a little, you know, loading ramps. Make sure your curbs all look legitimate. All right. So it's just another one of your tools that you're going to be able to use to evaluate this information. All right. And then we can exit. Oh, there's a draw button that allow you, let's say your boss comes by and says, well, cut me a section across there, which is not really technically a section, it's a profile. So you would just go to that quick profile and which is on our surface menu, quick profile. And I think, well, let me do it from here. Yeah, see this draw. They say, oh, okay, well, draw me that. So you can choose draw, and it's going to have some grids and setups. You can have a vertical exaggeration or not. Let's put it at, say, 20 and 20. We'll just come over here and draw it. And so there's now a drawn profile. And then you've got, so all of these settings, the elevations, the stations, the layers, the grids, all of these are controlled uh, by that draw profile button. It puts you in there. I just took the defaults and showed that you can create that as a real quick means of evaluating some of this data. Okay. So that being case, we have reached our morning break point. So when we come back, we're going to look at how we build surfaces. We're going to triangulate and contour. We're going to look at some different tools and how to go about fixing them. We're going to look at the boundaries and the borders, and to use those parameters and such. And then we'll have our lunch break, and then we'll come back in the afternoon and we'll spend that using to do that little workflow, total type of workflow the rest of the afternoon. So any questions to this point? Everybody good? Okay. So it's quarter till. Let's come back at the top of the hour, 11 o'clock, and we'll pick up where we left off. All right. I'll see everybody then. Okay, now that you've seen a number of tools to help you evaluate data in your drawing, and you've seen a couple of modification tools that you can use, let's look at one other quick little tool that a lot of people miss entirely, but is really quite helpful when you are drawing things and have to create things. If you'll do this, let's go to the View menu, and let's choose Show Hide by Selection, and let's choose Isolate by Selection. Now you can do this in AutoCAD directly by doing this. If I want to take these two contour lines right here in the middle of the site, and you can, if they're selected, you can right click and choose Isolate and Isolate Objects. That does the same thing, but if you're using IntelliCAD You can do it with, if you've got the layers toolbar, it's this button right up here, or it's on the view menu, show hide by selection. Let's isolate by selection. Now it clears what's selected, so you have to run the command first and then choose what you're looking at. So let's just isolate these two items. And this is a tool we're going to go to next, draw a 2D polyline. You can do this with a 3D either way. Well, in fact, let's do that. I'm gonna cancel that. Let's go to draw 3D polyline. And now some of the options here for a 3D polyline is you can prompt for an elevation or a slope. So when you pick a point, it's going to read that point's elevation. So if you snap to an object that you're trying to connect to, it will read its elevation and offer that. You can either type something else or accept it. Or if it's out in empty space, I'll give you an example. I'm going to say okay to that, and I'm going to snap right here on this endpoint of that contour line. And notice down here it says 13, 15. Oh, wait a minute. Sorry, I forgot to set the switch. But draw the 3D polyline and turn on prompt for elevation or slope. And you can put in an elevation adder, for instance. Let's say you're designing a water line and you want that to go 4 feet below the ground. Well, you can snap to these things that are on top of the ground, and you can put in a -4 elevation adder, and it will create that 4 feet below where you're showing it to go. All right, so that's some of these different things. Now, a dual 2D polyline means it will create two lines, one 2D, the other 3, and the 2D stays down at 0. But anyway, let's turn on prompt for elevation slope. Let's say okay, and let's snap to the endpoint of that one line. It reads that elevation. You see it's down here on my command line as 1315 as an elevation. So I'm going to say okay. I'm just going to hit enter because it's in the angle brackets. And so now the next point I'm going to choose, I could either go straight across and snap to that, or let's say I'm going to pick here in open space. I'm going to take a little circuitous route around there. Now I picked there and it says, okay, what do you want to do? And it reads and offers the same elevation that it had before, but I want to say I want to interpolate. So I'm going to interpolate until I finish setting these things here. It says go to the next point or elevation or keep interpolating. I'm going to keep interpolating. Now I'm going to go here and it reads, it says this point elevation will be interpolated upon completion. All right, so uh, make sure that that did in fact interpolate correctly. Yep, so that went from 1315, where'd it go, down to 1315. I missed something here. It should be, all right, that's 1310. All right, try this again. So if I draw a 3D polyline prompting, so I'm going to say, okay, I'm going to accept that and accept the 15. And I'm going to click out here and I'm going to say interpolate. So I hit enter, hit here. I'm still interpolating. I hit enter. And now I hit up here and I type E for elevation. And it reads that elevation. Yes, that's what I missed. I didn't hit the E part down here. So that's going to be 1310. Okay. And then I'm going to click out here again and I'm going to I to interpolate. And I'm going to keep going down to here. And at that point, I'm going to give it an elevation. So I type E and let's call that one 1300. Now, if I look at this, And if I hover in each of these grips, notice down here at the bottom, I've got my coordinates turned on. If I hover in a grip and it snaps into it, I read that elevation at 1315. Then there's 13.3, 12.31, blah, blah, blah. Or you notice with your inquiry drawing inspector, I'm going to right click and turn the layer name off. I don't need the layer name. If I look at this, there I am at 13, almost 1315, and then it starts to work its way down. Oh, let's turn on our polyline data as well. And you see that slope, negative 4.55% until it gets to here. And now it's going to change slope at negative 2.4, and it's going to go all the way down as I wind my way down here to 1300. All right. So those are some of the tools that you can use. I'm going to turn off my drawing inspector now just to get it out of the way. All right. So that's one of the things. So make sure that you pay attention to those options down here at the command line. Now, here's another one that this is what I was actually starting out to show you. If you draw let's just draw a 2D polyline this time. And this time, oh, by the way, if you draw a 3D polyline, and if you have this off, it's not going to prompt you for those. It's just going to read the elevations where you go directly. So if I start here, it's going to set that at 1315. Now you can still do the interpolation. I'm going to click there, and then it says warning the last 3D poly. No, apparently it's not. You do have to have the prompting on. Okay, so keep that part in mind. All right, so now let's draw a 2D polyline. And this time, let's show one of the other commands. So I want to start, say, right here. And I want to go across to here and then follow around this line up to some point and come back around and close it, okay? So I want to say, I'm going to go to, I want to follow. So I'm going to say F to follow. That's one of my options down here. So F to follow, or click on it. And it says select the polyline to follow. All right, I want to follow that polyline. Now it says, well, pick the first follow point. Well, I'm going to start right here. Okay. Do I want to interpolate the elevation of the vertices? Well, it doesn't matter. I'm going to say no. I'm just doing a 2D. And it says, give me the last point you want to follow or a particular distance along. Well, let's say I'm going to go up to this point right here. All right, so see how it follows around to where I last created it? And then I can do a couple of other things. I'm going to follow now again. I'll follow here, follow this line. I'm going to connect there and give it the last follow point would be here. And if I wanted a closed polyline, I'm going to say C to close. So now I've got an enclosed area that I didn't have to try to go snap, 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 snap all the way around these areas. I just was able to follow something already in my file. Now, that used to not be an option in AutoCAD, but I think AutoCAD now has, if I just draw a standard P line, and if I go here, you see, no, it doesn't. I thought AutoCAD had added that functionality with the standard polyline. It doesn't. All right, so apparently you'd have to snap your way around it. So that's a nice little tool that helps you to maybe put in phase boundaries to follow irregular outlines of certain areas very quickly. So, keep that part in mind. It's sort of like, you might be tempted to say, edit, copy, polyline section, and you copy those out, and then you draw the connections and you connect them together, and you can do it that way, but it's much simpler to just choose that follow option and do that. Now let's do this as well. Let's draw a 2D polyline. And I'll make this, say, green. And I'm just going to go, say, from here to 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 here, and then I'll close it. See to close. All right, so I now have a closed figure. And so if I choose that command again, I'm going to repeat 2D polyline. I'll change the color so you can see what's going on. And if I, do a couple of things. Now I want to follow part of this thing. I want to follow from this point down here up to this point over here, okay? So I'm going to say F to follow. I'll pick this line. I'll pick the first point. There's my follow point. Now I say no for the elevations. Now I can either show it the last point or give it a distance. Well, I'm going to show it this point. Now watch what happens because this is closed. There are two routes. When I do that, it's going to say, is this correct? Yes or no. And if I say N for no, it will go around the other route. Is that correct? Yes or no. And you can just keep changing it until you're happy with it. I'll say yes, and then off you go, continuing on your way. Okay. So those are a couple of additional tools that Carlson gives you that you can't get out of drawing a standard polyline unless you want to snap, snap, snap your way to it. Now, one other set of commands that's very useful that I use quite a lot is I'm going to take this line because that's part of my data set. I'm going to leave it alone, but I'm going to copy that. So I'm just going to do a standard copy and I'm going to put it up here. And I might as well change the color just to make sure I can get rid of later. And I know that it's sort of foreign to me. Now, let's suppose I need to straighten out some of the kinks in this. So how do you get rid of these vertices, a few of them that you might want to get rid of? All right, if you're using a standard p-edit command, let's say I want to take this little rising hump out of this polyline, okay? So you can do a couple of things. You can do the p-edit command. I double-clicked it. I'm now running the standard AutoCAD p-edit, and I need to edit vertex. So that's going to put me in another subsystem. And now it starts me off at the first one. Well, I have to go all the way up by next, 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 until I get to where I want to be, right there. And now it doesn't say, there's nothing down there that says remove vertex, but the option is to straighten. So I'm going to choose straighten. All right, and it says, okay, now what do you want to do? Well, you're going to go next, 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 and there's where you want it to straighten. So you're ready to go, and you're going to press the word go. So there's go, and now you have to choose exit to get out of the subsystem, and now you're ready to conclude the command. You hit enter. All right, so that's one way. That's the old way of doing it. I'm going to undo that. And here's another newer way with AutoCAD is you can go and hover over a particular vertex and say remove vertex, and you can do this, and you have to sort of, work your way around it, much like the same. So it's still sort of tedious. And then you would do the same thing. Okay, so that's probably where I want, oops, and maybe let's get rid of that little one there too as well. All right, so you could have done all of that. I'm going to undo that back to where I was. Okay, now the Carlson way of doing that, instead of doing it through that really arcane, I think I've got a few more I got to get rid of. There we go. So instead of doing that really arcane p-edit command to choose straighten to get rid of them, Carlson has a command that just says, I'm going down to edit, polyline utilities, and I'm going to choose remove polyline, which doesn't mean erase the polyline. That means these are commands that remove things about the polyline. So I'm going to remove a polyline vertex. Okay. And so it asked me to pick the polyline, and now it shows you these little glyphs of where they are, um, just as a little reminder. And now they're just there. So if I move around or zoom in or out, they go away. But all you have to do, and you don't have to snap to it, you just need to click and be the closest to that particular point. So I can be out here and just say, just start clicking out here. And so the closest ones that it finds are going to be the ones that it gets rid of. So a lot easier, in my opinion, to help you edit those vertices is using that command. Now notice some of the other ones under Edit, Polyline Utilities, Remove. You can remove a polyline segment. Now here's another little clue to help you learn the system better. You see those two little icons to the left of those commands? That tells you, if you see an icon next to a command, that tells you that that command lives on a toolbar somewhere. It doesn't tell you which, but if you see a command there, it's on one of the toolbars. I mean, if you see a icon. Now, as it turns out, one of the toolbars, the one that I have up here called Polyline, let me get out of that. If I hover here and I see there's my Polylines toolbar, and I've got a number of tools on it, and they come from different menus. There's Extend by Distance, there's a Boundary Polyline, there's Join Nearest, there's a Reduce, that's like your weeding function, there's your Densify, you can smooth them, close them, add a vertex, you can add some intersections where it crosses other line work, and there's your remove polyline vertex, and there's what the icon looks like, a little pencil eraser over a red vertex. Here's a little pencil eraser over a red segment. So you can do, let's say, take out a segment. So I'm going to click that segment there, and you see what it does is it breaks it for me. I don't even have to, I don't have to go through and break at a point and break over here. I can just have it do that. If I choose to erase the polyline vertex from there, I'll choose the polyline, and now I just start, cleaning out the ones that I don't need. Okay, so Carlson's approach to polyline editing is they're going to give you a number of different tools. So I had those remove functions. I've got the edit functions where I can add different things or change their positions. So I've got all of these different things I can do as separate commands. AutoCAD's approach is to give you one command called pedit and give you all these arcane little submenus and tools that you can use, but they do it all with one command. All right, so two different approaches. And I just think the Carlson tools give you a lot more control over what you're trying to do. Okay, so I'm going to edit that and erase it. Now let's get back into our surface modeling and figure out what we're going to do with this stuff. So I'm still left with my isolation. You can either right click and choose isolate end if that's the way you did it, or you can go to the edit menu, the view menu, show hide by selection, and you say show all. That's going to put them back. Okay. Now, let's take a look at what we have. We know we've got some contours shown here, and we also have these 3D polylines, which are the break lines that the aerial mapping company used to create the contours that they drew in here for us. So let's freeze the break line layer so that they don't show. We can pretend they're not part of the file. So that's on our view menu as well. And you can freeze a layer by pick, or again, take it from the layers toolbar. And I'm just going to pick one of those white lines. And now let's say this is a file that an outside agency has done for you, and they've given you this file, but you need to create an existing ground terrain model so you can start doing some of your design work. And you look at this, and the contours are all good and they look fine. So you say, all right, well, I'm going to use that to build my terrain model. Okay. Now, one thing I want you to realize, using contour data to create a terrain model is probably the worst kind of data that you can possibly use. The reason being is that every triangle is going to get formed by sitting on each one of these little vertex points and looking around itself and trying to connect up to another one that it sees to make these triangle edges. And what that means is if you're only considering these contour lines, it goes from, say, here up to here, and that change is linear. It's a consistent change. Now, what happens though in reality is that the ground here might go up or down a little bit. We don't know. And so you wind up with a bunch of, they're not, they're not level, but they're sort of flattish triangles. They go from one elevation up to another across the entire uh, part of that triangle. That's all well and good, but then look what happens over here in a situation like this. It'll sit here at this point and look around here and find that point, and that triangle might be legitimate, but then it might also sit here, come to the next point, and it starts making triangles over here across to itself. And that makes flat triangles, and those are level because they're all the same elevation. But in reality, what do we know about the ground right in here? Because we're coming from this contour line up to this contour, up to this contour, then right in here, this ground elevation is really lower than the contour line to its left and to its right. It doesn't become the same elevation until you get all the way up to the contour line. But we don't have that information with just our contours. So what can you do? Well, you could do something like draw a 3D polyline. I'm going to uncheck the prompting. I'm just going to have it read the elevation. I'm going to snap right there. It's read the elevation. And I'll go down here and snap right here. And it reads that elevation. And then I can include that. And that becomes a break line. And that keeps these points over here from looking across that line and seeing that point. So it's only going to be able to look up to this line and this line to be able to create those points. Okay. Now I need some additional points along this line for it to make little triangles across the partials. Otherwise, it can only go up to the end point and its other end point down here. Okay. But, sorry. But one of the things that you want to probably avoid having to do is to go through here and find all of those little areas, like all down this road, and you have to put in all of those little break lines. Like you could say that could be a nice, or sorry. Sorry, if I select this, and I might want to turn that into a break line. Well, I've got to give it the elevations every time it crosses these other contours. I have to turn that into a 3D polyline and make those the elevation to cross those points, which is a non-trivial task. Okay, so I needed to really have something else that was in there, and that's the layer that we froze. All of those break lines they put in legitimately, but just to show you what happens is I want to isolate some layers here because I've got some points in here. If I select all this, you see those points that sort of highlight in here. I do have some points in between, and it would use those to make triangles, but I'm just going to show you if all you have are contours, here's the risk that you run. So let's go to view and let's isolate layers, and let's pick one of the index contours, one of the intermediates, and then go over here to this, to the side where you see these dashed contours. They're done on different layers because they're done in a obscured area, so they're not as accurate. So I'm going to select one of the indexes and one of the intermediates there, and then I'm going to hit enter. So now all I have are these contours. And if I select those and look at them in my 3D viewer, or if I spin the drawing up, I can see, hey, those look pretty good. You know, that looks like that would be my surface. So I'm going to make my surface based on that data. All right, so let's do that with our command to make a surface, which is on our surface menu, and it's called triangulate and contour. They sort of give you two commands in one. Normally what I do is I don't draw the contours as part of that process. I usually save a file and then I'll run contours from 10 file later on to see. But let's just go ahead and run the command like it is. So triangulate and contour, and I've got several different tabs across the top here. And looking at the selection tab, first you see that you can filter based on inclusion and exclusion areas, or you can specify certain selection options. So let's say you have these and you know you've got some points in there, these CAD points, you could turn that off, not use the points, or you could say, I only want to use Carlson points or 2D, you see what I'm doing is I can take those out. Inserts mean use blocks and use their insertion points. I can have elevation text that I can read and have it add to my surface. You could also read straight from a coordinate file. So let's say you have a coordinate file that's just got thousands of points in it. Well, you don't want to necessarily draw locate points and put all those points in your drawing. You certainly could do that and use them. But if you didn't need all that overhead in your drawing, but you just wanted to read the file, then you could tell it that you want to use that file. And it could be, if it is a coordinate file, you can say it's a Carlson coordinate file, or it could be an ASCII or text file, and you could choose one of these different options as to how that data is organized. All right, so those are ways that you can filter your data. Normally, we don't have to do much here, but always sort of get a habit of when you run the command, pop over here to the selection, make sure you're not filtered for something else, okay? Now on the triangulation tab, this is where we set up some of the behavior. And then on the contour tab is where we draw the contours, and the label is whether or not and how we draw the labels. So I'm going to go to the contour tab and I'm going to uncheck draw contours just to show you what's going on here, okay? So if I turn that off, the label tab is completely inaccessible because there's no contours to label. So let's just go back here to the triangulate tab. And the first thing that you'll see is this right triangulation file. And what that's going to do is it's going to create this tin file, this .tin, and it's going to save it on the disk for you. And that way you can use it later on. You can load it up in a completely blank drawing and draw contours from it. You can cross-section it. You can do anything you want with it. So let's go ahead and turn that on. And let's choose the select button on the side. And let's choose the file. Now I'm going to get into this AutoCAD weird thing with my waiting on my file selection to come up. I don't know what's going on with this. I think Zoom has some kind of a bad influence on this. I don't know whether that's causing it or not. I don't normally get this. Just give me a second. Sometimes if I can turn it down and back on, sometimes it'll come back up. Oh, uh-oh. Didn't mean to do that. Get rid of that when it comes up. All right, so we're finally back here now. Let's see. All right, so it's asking me for a file to write. I'm in my dataset folder, and I'm going to call this EG from CTRS, existing ground from contours. I'm going to say save. Okay, so now I've got that. It tells me what the name of the file is, and I can choose to draw these individual things from it if I want. I'm not going to draw any of this yet. The triangulation lines would draw 3D lines on a particular layer that it uses when it makes the triangles. But I'll show you in our viewer that we can see those anyway. We don't have to draw them here. We can draw them later if we ever needed them. Or you can draw them as triangulation faces, so they become 3D faces. And then when you look at them in the viewer separately as an object, you can see them as solid objects, etc. So we're going to leave all those unchecked. Now we're going to uncheck this use inclusion exclusion areas for right now. We're going to say the shrink wrap perimeter reduction, we're going to say is none. We'll come back to that later. Erase the previous contour entities. Let's pull that down and say all contour entities. So once it creates anything, it really should say surface entities, but it's the way the programmers made it. So we're going to say erase all of them. So if you've drawn the contours and you want to go back and rebuild the surface, this clears out all of those drawn contours so you don't accidentally include them in the new surface build. So I'm going to leave that as it is. I'm going to ignore 0 elevation. So again, if we had other data that was down at 0 and it was in our selection set, it would not do it. It would not look at it. And again, you can filter based on a couple of things here. And you've got maximum edge length for interior and exterior triangles. Now that's one way that you can get rid of these exterior triangles, these long straight triangles here that that are going to form. You're going to see how they form because of this. All right, so we're going to turn on the ignore 0. We're going to uncheck any of this kind of stuff. Everything else is unchecked, and we're going to say OK. And now we're going to follow the prompts. It says select objects. Well, your first impulse might be to select everything. I want you to get in the habit of always reading the line above when it asks you to select stuff. So it says now select the points and break lines that you want to triangulate. Well, these contour lines are actually break lines because they prevent one contour line from jumping across and seeing the other one. So we're going to now, in this case, select everything. I'm going to draw a window around it, or I could type the word all and hit enter. Now it still says select objects, so you can continue to select additional objects. We're done. We hit enter. Off it goes, and it says, okay, I inserted 9,000 break line segments. I wrote this triangulation file. And you might say, oh, whoop-de-doo, I'm done. I've got a surface file. I can now go to work. All right, that's true to a certain extent. But let's take a look at that surface file. So let's go to the view menu. And now let's come down here to our 3D view, and let's look at the surface file viewer. Now, this is the very same viewer as the drawing viewer. The only difference is it reads the surface file and loads that up into the viewer instead of us selecting things in the drawing to look at. Now, you can do them together. You can select all of this information and then add the surface file to it, or you can look at it from the surface file, read the file first, and then add drawing things to it. And sometimes we do that to try to get a sense of, where there's some particular errors. But let's just for now look at the surface file viewer. And that's, here we go. So it's going to ask me to pick a file. And there is my file. Notice it's in my recent files. It's also up here in the current folder files. Either one is fine. I'll just double click it. And it's going to read that file and load it up into my viewer, which I can reposition, resize. So I'm going to do it like this. I'm going to go to my settings tab, and I'm going to turn off this display contours for right now. And I look at that and I may be tempted to say, hey, that looks pretty good. That's my surface, and off I go. Or if you also wanted, you can display your contours, and it's going to generate the contours and put them at whatever interval you want. Let's say if I only looked at every 5 foot, or if I wanted to look at every half a foot, it's going to draw those. Well, to match what we had in the drawing, let's put them back to 1. So that's what it looks like. And in general, it looks okay. But look up here. You see these contours in here? They're not in their drawing. Okay, but when it triangulated from the edge of this one contour out to this one, and from this back to here, it created that as part of that surface. And also look over here on this left-hand side, you see those long areas here. Now let's uncheck the contours for a minute, and let's display the triangle edges. And now you can see all those long skinny triangles. So those triangles need to really not be part of this data. Okay, same thing down here across the bottom. You get those long skinny triangles. So how do you get rid of those, for instance? And we're going to do that by using a boundary across our data sets. And we'll come back to that in a minute. You might be tempted, and if I go up here to the top of my tabs and I choose the view control button, this is where you can do things like, and if you choose this arrow icon, then notice it activates this 10 edit. So I can actually go and edit this 10, one of which could be remove triangle. All right, so if I do that and I move this around, and I'm just going to, I'm going to double click in these triangles, but you can see that can take you a long time to clear all those things out of there, right? And then once you do that, and see there's one real skinny one right in here, maybe two, oh, just the one. So you could do it that way. And then when you exit, it will ask you if you want to save the triangles. Well, we're not going to save that edit, but that's just one thing you can do. Now, so I've got some weird triangles, and up here was where that little ramp looking thing, if I turn my contours back on, see right in here, that's because these triangles formed from the ends of these contours all the way down here to that one from here. So it made these long flat, or not flat, but long triangles from one contour down to the other, and it made it consistent. That's why those contours are fairly evenly spaced. All right, so, but they're still not very legitimate. I'm going to turn off my contour triangle edges again. And let's look at my contours, and let's look down here at the roadway. And if I look here in my road edges, I notice a couple things. Nothing really stands out to me here, except I see this contour comes around here, and instead of going up and down like it does in the real drawing, it cuts across because it made a flat triangle right in here, because the original contour line read across to itself and it made those flat contours. Okay, so let's leave these showing, and let's go to the model tab. And now we can do things like we can add either another surface to compare, or we can add entities. That's this second button. So if I add entities, I'm going to come back here and I'm going to select all of the original contours that I used to model the data. So they're now showing, and now you can see right in here, the contours that the surface file generates are these yellow ones. Now where they match, they're superimposed. But you see, it gets here and it reads across to itself. So it made the contour go like this. And it really should have come all the way up to here and gone back down. But right in here, it's assuming that's a different elevation than what it really happens. I look over in here and I don't see any of those green contours, but I see my generated yellow contours. Okay. I can even, let's say if I go back to my view control tab and I choose this little shading toggle, I can turn off the shading of those triangles, and I can see now where my triangles or where my contours differ from the displayed contours are all these yellow places that you can see sort of over top of the original contours. All right, so we know we've got some problems um, that we can see. So I'm going to turn this back on to view. I'm going to go to settings and I'm going to turn off these contours, and I'm going to go to the model tab, and I'm going to open up the layers side, and I'm going to turn off those displayed, whoops, contours that we added. I'm not going to look at them. I'm just looking at the surface. All right, now let's learn some of the tools about how to look at this surface. Right now we're sort of in, well, we're exactly in plan view, but how do you control how you look at this? How do you spin it up and look in 3Ds and all that kind of stuff? And there's a couple of things to keep in mind here. If you look over here on the right hand, and I'm on the view control tab. First of all, I'm going to ignore any zeros, and I can do this. I can choose color by elevation, and let's just turn it on. All right, so now you can see a range of, say, blues are lows, greens are mids, and reds are high. And you can change those colors over on the setting tabs if you need to. Um, but you can see that, what you're looking for is you want to see a fairly even distribution of that color range. If everything looks mostly blue and you got a real hot spot that's over here that's high, then you've probably got some kind of an error in the data that you're looking at. Okay, so, and this also gives you a set of numbers, say from about 1280 up to 1340, so you can sort of get a sense of how that range works. And you can turn that back off and just look at it in general. You can also, as we did the other day, under settings, we can say use the bounding box. And so if we show that with the box, we see, okay, that looks fairly decent. When we spin it up like this, we can see, okay, that contains, it looks, fairly legitimate. I'll go back to plan view, and I'll go back to settings, and I'm going to turn that box off. So now back to the view control tab, let's talk about what we can use to help us view. We've already seen this little toggle switch that makes the triangles solid or not. Okay, and that helps us to visualize. And again, these triangles are just being read out of the tin file. They're not actually in the drawing, okay? But you can see how they formed from this contour line, jumped across to that contour line, same kind of thing. All right, that's the only data that we had were those contours. All right, so now, what else can we do? Well, if we got this little thing right in here, this blue circle and the little yellow square, and if you think about that as the blue circle represents, say, the sky, you're looking down on it, and that's the earth that you're looking on. And the little yellow square you can think of as the position of the sun. Okay, that's the light position. So if you click and hold that and move it around with the mouse, you can see how it changes the direction in which it casts shadows. Now, the reason it normally comes in up here in the Northwest is that we are, as visual people, sort of conditioned to think of shadows being cast down and to the right. Anytime you see like 3D text and stuff like that in advertising, you typically see that where everything is sort of cast down and to the right. So if the light source is up and to the left, it's going to cast shadows down and to the right. And then, of course, you've got brightness, contrast. You can adjust those as you need. Okay, now, what else can we do here with viewing the surface? We might want to change it, and spin it around in 3D. And so there's a couple of ways, or not a couple of ways, there's, ways to do that. So if you choose this icon right here, the one that looks like a 3D colored cube and a little rotation arrow around it, that's the really workhorse icon that we want. Okay, so if we choose that, we're going to move the cursor over to our data. And you notice when we're outside the data, it has a Z shape with a rotation. That means it would only, when we click and hold the mouse, it's only going to work around that rotation. But if we're over the middle part of the data, and notice it's not exact, so you see where it switches, and it really technically should switch out here. But when you go in this area, then it's going to give you a chance to spin around the Y and the X axis. And if you're off to the outside, you're going to be able to spin around the Z axis. Now these over here on the right in the panel show you how you can rotate things around. So if I rotate, say, around the Z axis, you can do it like this. You can do it like this. Okay, I'm going to go back to my plan view. But here's the easy way to do it, and this will soon become second nature to you, I promise you, because you use it all the time once you understand how to be able to position yourself to look at something. So let's say I want to look from back in here down this roadway so that I can sort of evaluate the edges of the road, which should be nice, sharp little valleys. Well, how do I do that? Well, if you grab that icon and we come over here and we put it over the data to where it's still showing as X and Y. Now let's make sure that we have this Y axis over here locked. The other two are unlocked. Okay, so we're not going to allow it to spin around the Y axis. If we do, if we unlock it, and then we're over here and we press and hold the button and push it up and then push it left and right and push it up and down, you see it frees it up. If we, I'll go back to plan view. If we lock it, however, and now we come over here and we push it up and down, and it goes around the X-axis, but if we push it left and right, it doesn't spin around the Y-axis. That's going to be helpful for us. And here's what you do. We have our icon that is this cube and the rotation. And what you're going to visualize for yourself is that you're standing out in your driveway and you're looking at your garage door. And you got one of those doors that's a solid door, it's not hinged, and you have to open it by grabbing it down here at the bottom and lifting it and raising it up into the top of the garage, into the rack. So we're going to go down here toward the bottom, making sure it's still XY. You're going to click the left button on the mouse and hold it down, and then you're going to push it up. And so what you want to do, and if you need to go back, let it up and go back and get another bite of it, you can do that. You want to push it up to where it's laid back at a fairly oblique angle. You don't want to go too far, and you don't, but you want to get it back at something like so. Okay. Once that's done, let the mouse up and then push it down to the bottom and click and spin it around to line up with where you want to look. And so right in there is where I want to be looking, is at this roadway. And then you can go back and sort of refine your positions, but say that's where I want to look. And now you just point to where it is and use the wheel on the mouse to sort of zoom your way in and out. And if you look at this road edge over here, I can say change some shadows and maybe see them a little better. You see that? You see those little sort of stair-steppy looking humps in the edge of the road? That's because that's where those flat triangles got created from those contours. And I can see that and say, well, that's not what my road edge, that road edge should be nice and crisp down that edge. Okay. So I can see that that part's not giving me very good data. And I can also, let's go back here and I'm going to reset it back to my plan view. And if I want to look across this little thing here, again, I'm going to grab my garage door and run it up. I'll spin this around to where I want to look down that edge, and I'm going to zoom into it now, and I can see, oh, hey, there's something weird going on with that. I may, check my shadows, and I see that, gosh, that looks like, And in reality, the site, there's a retaining wall right there. Well, that doesn't look very legitimately like a retaining wall. So I'll zoom way out here and then spin this back around and look on the other side and then maybe zoom back into it. And I see, well, that doesn't look like it was modeled very correctly, does it? Okay. So I'm going to exit my viewer and I'm see, I made edits. It wants me to save change. And I'm going to say, no, I don't want to do those edits. And I know that I've got problems with these edges of the road over here, and I've got problems right in here. All right, so a couple of things you can do is you could add these brake lines. So to get rid of that one ramp across here, I'm going to just draw a 3D polyline. And I'm just going to go from here to here, to here, to here. Then I'm going to come across to here, to here, to here, to here. All right. Now that should keep this contour from looking across and finding that contour because I had that barrier in the way. Okay. So now if I go back and rebuild the surface, I'm going to go back to the surface command, triangulate and contour. And this time I'm going to leave everything like I said it. In particular, I'm going to, if I had drawn any contours, which I haven't, they would erase them. But I'm going to say, okay. And the first thing it's going to tell me is it okay to overwrite that file? I'll say yes, I'll keep it that same file name. I'll set my data, collect everything, and now it also includes that break line. And so I've now done it. It tells me that it made the file. Now, that's what I want to point out to you, that even though it comes back and it makes a file and doesn't give you any errors, that doesn't mean it's correct. So if I go back to my view, 3D view, and I look at my surface file viewer again, and I'll clean this out after lunch. I'll restart everything on my Windows side so it resets it and it won't be quite so bad. Crampton, sorry about that. Just give it a second here. So there's now my file and it shows me an outline of it over here in my graphic preview. I'm going to open that. Up it comes. I'll resize, reposition, and now I'll spin this up and I'll spin around and look out here where I had put in that brake line. Apparently I didn't put it in the right place. Yeah, it's still jet. I needed to have closed this off instead. Maybe also I need more points along here, perhaps. But anyway, I have gotten rid of a couple of those. I can maybe add a few across here so that this can't see that. I need to put one from here, say across like this. So you could do all that stuff if you wanted to. And if that, sometimes you have to do that. You have to add those break lines in there. But fortunately for us, we have those break lines. So I'm going to go back to view and I'm going to thaw/on all layers. And these are the break lines. And if you look up here at our retaining wall, see there it is. And it's a 3D break line that is going to limit what gets used. So things on one side can't look across to things on the other side. And so now if you use that as your data, you can, um, eliminate that problem coming from just the contours. Okay, well, I'm going to go back to view and let's freeze by pick. I'm going to freeze off that one of those white lines again and show you one other thing that you can do to help, and then we're going to take our lunch break. If you go to the surface menu, triangulate and contour, notice there's a section right down here that
Yeah, I
says,
sent you the slab info. Oh, you saw it? Okay.
what's that?
No, they're only a foot deep, so I figure a half a foot. I can expand that
Hey,
on
Frank,
each side.
Frank,
Okay, I'll change that, and that'll change the next.
all right, Frank, you had your mic on. I just muted you, so no problem. All right, so now down here at the bottom, you notice there's a section that says adjustments for source data of contours. So if all you have are contours, one of the things that you can do is to minimize your flat triangles. And it looks at these contour lines, and as they go up and forms peaks, it's going to throw those away and try to use the other ones that aren't flat. So if I minimize those and take data, is it okay to overwrite the file? Yep, and we'll take all of our data again this time. It built the file. I'm going to go back and view that file again. So we load it back up and we take a peek at our data. We've got some minimization of down here. Let's look at the road edges. And now you can see the edge of the road is kept. And if I let's turn the contours on. So you can see over here, see how these contours are now sharp. They cut out those flat triangles. And let's go back to here. Now you see it's got a nice sharp edge down the roadway. So that's a nice little helpful tool. We still have some stuff over in here that might be illegitimate, and it is. And we still have this over here with this retaining wall. I don't have that long ramp looking thing, but I still have some spillage off of that. That should be a near vertical face. So, that would be one thing that you'd have to fix. But the minimizing flats took care of some of this stuff over here. Okay, and there's no way to really quantify how that's going to help, but it will certainly help some. Okay. And so one of the things to keep in mind is if all you have is contour data, and sometimes that's all you get, you want to make sure you minimize those flat triangles to try to get that to keep from happening. And then otherwise you're going to need to draw in the break lines down those triangle noses for ridge lines and valley lines. Okay, so when we come back after lunch, we'll look at building this file using the break lines instead of the contour lines, because what you need to realize, contours are really just an interpolation of a surface. Okay, and so they are an output. They should not be used as an input if you have other data, in which case we do. You see all the points that line up, and then we have those break lines that we froze. And so what we're going to do when we come back is we're going to turn the contours off and the break lines back on, and then we'll build the surface and we'll see the difference and how it comes in nice and crisp, and it will generate contours that will be real close to exactly like the contours that they included in their file when they gave it to us. Okay. It won't be exact in some little spots, but they'll be close enough that we can have the confidence that we've modeled the surface correctly. Okay, so that will be what we jump into after lunch and see about that and putting these inclusion and exclusion areas into our data and modeling things as we go along. All right. So with that, first of all, any questions? Anybody run into any problems? And if not, so we'll take our break. I'll go ahead and stop our share and I'll pause our recording. All right, so what we've seen is using our contours as our source data is problematic at best. Sometimes it's all we have, so you have to work your way around some of those issues. So let's take a look at using the other data instead of the contours. Now, I will tell you that if you try to use all of this break line data along with the contours, you're going to generate some errors where these break lines cross the contour lines. They might be, a couple of hundredths of a foot vertical differentials because they've probably smoothed the contours a little bit. So we're going to need to turn the contours off. So let's go to View, Freeze Layer by Pick, and let's pick one of the index contours. Might as well get the labels too, get the intermediates, and then into these dashed areas, turn those two off as well. And so now what you're left with are a bunch of break lines. And as you can see, those little things light up there. There are some points, just plain old CAD points. They're not Carlson points, they're CAD points. So we're going to use that to model the surface this time. So we'll go to Surface, Triangulate and Contour. And this time I'm going to change the file name. Wow, it goes back immediately to that delay. Try one other thing here. I'm going to switch to the IntelliCAD version and see if that's going to behave a little better. It may not. Okay, so let's go, excuse me, go to our surface menu and triangulate and contour and make sure there's nothing on my selection. My contours are off right now. I'm going to write the triangulation file. No, apparently that's a Windows thing and not a IntelliCAD or AutoCAD thing. All right. So we're going to call this version now, e.g. from break lines, e.g. from BL. And we're going to have the same settings. I'm not going to use any inclusion, exclusion areas at this point. I will ignore zeros. I will uncheck everything else. Nothing's on my contour and labels, nothing selected there. I'm going to say okay. It wants me now to select the things that I want to triangulate. So I'll grab everything here and off we'll go. Now, this is going to pop up a little error box because I've got some errors. And this is something that you'll see if you run into problems making the file. You didn't see the problems come up when you made the file from the contours. That doesn't mean that that surface is more correct. That just means it found some conflicts here. And there's three different types of conflicts you can get when you go to model your surfaces. You can have crossing break lines where something might cross over top of something else, and therefore, and it has two different elevations right at the points where they cross over each other, so it doesn't know which elevation to use. And if you just exit this and ignore it, it will use the one that it found first, probably. I don't know the rules behind it as to which one it uses. But you can see a couple of things here. It says I've got crossing break lines. I've got 3 errors there. Vertical edges, I've got 2 errors there. Now, the reason you can't have vertical edges is because when you define a vertical triangle, if it's in the vertical plane, it has a problem in trying to compute the difference between the surface and another surface because it tries to find the centroids of the triangles that it hits on this vertical sampling between surfaces. And when it drops down, let's say this was a bottom underneath surface, and it drops down the sample line to try to find the triangle, it sees the edge of a triangle, but it doesn't know how to find a point within it because it's vertically positioned, so it can't find the centroid of that triangle. It's only looking at the edge of it. That's why vertical edges are not allowed. So if you're modeling things like stair steps and curb faces that are in the real world probably vertical, you have to lay the top back just a little bit to keep that from happening so that you have a little bit of layback. And I'll show you how to do that in just a minute. So we got those, and there's one other one that where you would see one that's called T intersections, and that's just like crossing break lines, except they actually meet at a T. They don't cross. One goes up and just butts into the other one. But again, at that point, they have differing vertical elevations. Okay. So if you open up these things, it shows you each one of those. And in parentheses, it shows you the amount of vertical difference. And if you select one, you can see down at the bottom, the Z difference. So there's 800ths, there's 3/10ths, so that might be a problem right in there. And you see the little marker over in the plan view. As you identify these areas, it shows you where those are. And you can use that to help you find and correct these problems. So if I go to this one right here, I've got a crossing break line. I'm going to zoom 2, and that puts that in the center. And then I'm going to zoom in. I'm just going to keep collecting or hitting the zoom in until I get down to where I can look at it. And I see, oh, indeed, there it is. So I'm now going to click over here in my plan view, and I can see that this line, this 3D polyline, and that represents, it's on a layer, well, that's on the break line layer, but that represents a head wall. And you can see how it goes around like this. Now that's either the top of the head wall or the bottom of the head wall. And if I compare it to this one, see, that's also something else. It's either the top or the bottom. So let's evaluate these elevations. I'm going to just sit in the grip and hover, look down here on my status line. And see, that's got an elevation of 1313.04, and this one has 1313.63. Now let's compare that to these. And that one's got 1313.13. So that's higher than the 04. And that's 1313.93, also higher than the other one. So last let's check out this other corner. And I see for the one here is 131371, and that one is 131366. So that's lower than this one, whereas that one is higher than that one. So let me see, this one, 63, 93. So this one is higher. In fact, I see that's 1366, but this one's 1371. So they actually cross vertically in there. And if I look at those two things here in my 3D viewer, I'm going to select them. I'm going to choose my 3D viewer window from my toolbar. I'm just looking at those two things, and I can see it looks like this. So the people that did the compilation actually sort of made a mistake here. So you could either fix this or ignore it or send it back to whoever gave it to you and tell them to fix it. So one of the things that I'm going to do here, just to get rid of it, I'm going to make sure that this is going to be outside of the other one. And we'll just pull it out here to the bit. And so we kept that elevation there. And we'll come out here and keep that elevation there. So that's 1371. That one is 66. It's 93. And it's 63. So this one's higher, except for down here at this point. So I can change the elevation of that one to be less than, let's just match them up. So if that elevation is 1366, I'm just going to select it by properties. I'm going to look at the vertices. I'm going to set that one at 1313.6 just to keep it consistently lower than the other. So that might be the ground line, and then this line might be the top of the head wall, whereas this would be the ground behind it. So, whether we fixed it correctly, we don't know. So let's now look at another location here. I'm going to zoom to this other one, and this is a crossing break line. And I see when I zoom in down here that I zoom way in tight, that it actually does cross. So this line here actually crosses this line here. So the best way to bring that back is I'm just going to take that and I'm going to break it right in here and just knock the end of it off. So I'm going to go to edit, break, and I'll break at a selected point. I'm just going to break it right there. And then I'll get rid of it's like I didn't break it. Let's see, edit, break at selected point. So I didn't break this line. There I go, I broke it. I'm just going to erase that little segment. Now there's a 2D polyline underneath it. Again, that's what they use for the mapping part of it, but these 3D lines are above it. So I've trimmed that one back. And if I go to this third one, I zoom to that area, I'll zoom back out now. And I'll see, okay, that's where those cross. I've already fixed those. And I'll look at our vertical edges. I'll zoom to that location. And I'll zoom in. And so now I see that when I look at this line at that spot, it's 1293.72. And I look at this line, and it has another vertex right there at 68, whereas this one was at 72. So a slight difference. You can either make that jump to that location, or in this case, I'm just going to drag it back so it doesn't go all the way up to it. So now I fixed that one, and I'll now zoom to this spot and do the same thing. I've got this line, sorry, this line compared to this line. So that one is at 1300.81. This one is at 1300.80. So I'll take this, change its vertex. That was the last one. So instead of 81, I'll just make that 80. All right, so that should clear those. And I'm going to exit, and I'm going to just rebuild the file. So I'm going to triangulate and contour, leaving everything like I had it. I'll say okay. And I'll select all my data. And now still, we got some other ones. I've got two categories, 0 and 0, but it filtered out 17 errors because they were below the tolerance settings. And those you set over here in your settings button. And I'm saying anything less than 100th, don't worry about, because it'll take one of them and use it and discard the other one wherever that happens. So in this case, they're within 100th. I'm good with that. I'll say okay. And I'll just exit the box. It's already made the file. And so there it is. And if I take a look at this file now, and you'll notice quite a bit of difference once this comes back. Yeah, this only started happening after I upgraded everything to Windows 11. So apparently there's a conflict there. And the new upgrades to Zoom as well. So there's some problems. All right, so once this comes back, now I'm going to look at my EG from break lines file. And you should see, now we still have the problem with these long skinny triangles in the edges. We'll fix that in just a minute. But look at our roadway. Look how nice and crisp those edges are along the edge there. And you also notice here, there's a flat sort of a sidewalk. You can see how it comes up the curb. You know, there's a little asphalt curb that fits there. And you can see all of the curbs now are nicely defined. And even these retaining walls, go back out here. And we'll look down the face of this retaining wall now, where we saw before that long looking ramp kind of thing. So now we've got everything modeled the way that it should be modeled. And then there's a couple of other ways to evaluate this. Again, by your color. And there's that similar type color distribution. But there's another way that you can take a look at things. Again, now that we have a surface built, let's use that quick profile. We'll go back to surface and choose quick profile. And let's make sure we're using a surface file. And these file names are going to be left over from the last time you ran the command. So now you can do up to 2 at a time. So let's look at them both. So my first surface, I'm going to look at the EG from contours. And my second surface, I'm going to look at my EG from brake lines. Say okay. And let's take a look at going across the road here. So I'm just going to pick a starting point. I'm going to come here and go across the road, and I'll say enter. And now you can see, okay, there's some differences out in here because we didn't have contours out there, but we had the brake lines. So now that looks like a fairly decent match until you get over to here. Now look at the red line, and it's the red line is that brake line file. You see the red is where it's incorporated the little wedge curve and the flat area, whereas the white is where it made it between the contours. So you can see that difference. And if we adjust the alignment, and let's scroll this down a little bit so we can see both sides of the road. All right, now I'm going to adjust the alignment, and I'm going to pick near the middle, and I'm going to just move it back and forth, and you can see when you get to some areas. Oh, you know why? You're not seeing those now because the last time we did the example or did the existing grade from contours, we said minimize flats. So that's why you're not seeing those little stair steps. Let me demonstrate that here briefly. I'll use this, place it, and I'm going to not use these cat points for a second. And I'll gather all the data. Off it goes, and it's now built the file. So now when I do that quick profile, I'll just leave the file names the same. I'll come across the road, and now you should be able to see the difference. So I'll zoom this up here so you can see where we are. I'll zoom this down here. You see that little bit difference if I adjust. And if I move this into some of these areas like right in here up at the sharp nose looking part of the contours, and now look at that down here. You can see some differences there. It's not as visible as I was thinking. There, whoops. Yeah, try to see it right in here, for instance, and then come down here. So here you can see where the one surface, this white line, that's from the contours. That's where it made those flat triangles. whereas the red surface is from the break line. So you can see the importance of having those break lines. Now we had, remember up here at this retaining wall. So let's do, while we're here, we're going to adjust the alignment. Let's look at it right in here. And so now you can see, let's see if we straighten that out a little. Unfortunately, you have to do that twice. So there you go. So now with that in mind like that, you can see that that's where those long contours went out, looked like that loading ramp up that wall. So you can see that the retaining wall using the break lines got modeled correctly with the red line, whereas the white line surface is what we built from the contours. Okay, so just another way of evaluating those surfaces. So hopefully you can see how that works. Now we still have the issue of all of these skinny triangles that were down in these areas and down in those areas. So let me turn, oops, sorry. Let me turn all my layers back on, and I'm going to freeze my contours now because I'm going to redo some of this stuff. All right, so I've just got break lines and points. I'm going to make a third surface now, except this time I need to do a couple things. So if one of the things on our command dialog, we did triangulate and contour, was to use inclusion and exclusion areas, yes or no. And if I say yes, then how do you want to do it? You want to trim the edges at the boundary, or do you want to remove the entire triangle if it crosses? Well, we're just going to trim it, so it's going to just slice it right off at the boundary. Okay. And I'll say, okay. It's okay, I'll write a file. Oops, I mean, cancel this, escape. So I need to actually first, I have to draw a closed polyline. Now this can be 2D if I want, and we'll just put this on a layer called topo-bdy, and let's make it red. Say, okay, now I'm just going to draw sort of an arbitrary boundary here. Oh, let's go up to here, down to here, back to here and close it. Okay, now let me make that layer big enough to see. And so if that is going to be my inclusion boundary, and I'm going to make another, I'll just draw a rectangle in here. And let's draw one more. We're going to use that as an exclusion boundary. So if we go to make that surface, so we're going to triangulate and contour. And this time I need to make a new file, so I have to wait on the file picker to come up. And I'm going to call this one EG from BL with inclusion. Let's say with boundaries. There we go. And this time I say use inclusion, I'm going to say okay, and now it's going to come back here and it says select entities. And this is why I say get in the habit of reading this line first. And it's selecting entities. So select the inclusion perimeter polylines. Notice they can be more than one. So you could only be looking at one area and then over here another area, and it becomes all part of a single surface file, but it's in different pieces. But there's my inclusion, select entities. It tells me I found one. I'm through selecting inclusion entities. I hit enter. And then select any exclusion polylines. Well, let's pick those two rectangles that we drew and hit enter. And now select entities again, but this time it says now select the points in the break lines you want to triangulate. Well, I'll go here and grab everything. So it's going to come in here and give me those little crossings. What happened here? These have elevation apparently. Yeah, 13, 13, 16. I said that should be 0. That should be 0. That's a 0 elevation, and that has a 0 elevation. Make sure this one has a 0 elevation. That's good. All right, if I draw a 2D, okay. All right, so now back to our triangulate and contour command. Say okay. Yep. And selecting our inclusion, finish the selection. Now select the exclusion. Finish the selection. Now select the data, and I'm getting everything, even though some of it's on the outside of that. Now I do have that particular 3 places where they cross. I'm going to ignore those. And now when I look at that surface, I'm going to see the effects of that inclusion perimeter and the exclusion perimeters. And there you can see it just made those areas that were excluded undefined in the middle. And it only went out so far as the outside boundary that I had. Okay. So that's a way we're going to be able to control what we do. Now, you may notice in this file, in this data set, let's see, get rid of this guy too. If I turn on the contours again so you can see it, if you look at, and I'm going to toggle this layer on and off. If I freeze those break lines, you see the edges of these contours? Now sort of get an idea in your mind of where those are. And if I turn the other layer back on, you see how they go out beyond it? That's the way this particular company compiles its data. It compiles outside of the area and then it trims it back and delivers the contours just back. It's usually, I don't know, 50 feet or something that they use to cut it off with. Okay, and you can do that if you want as well. Now I'm going to go back and I'm going to freeze these contours again. And we're going to talk about making those boundaries. Now, if we want to use everything of our data set, but we don't want to, we instead of just arbitrarily drawing a boundary, although you can, and you can do it like this, you can just sort of, eyeball your way in. Up here, you can snap your way around everything. Come up to here, and then maybe go all the way across to, say, here, and down this edge, come up to here, and maybe come up to here. And then let's just close. So you can do that. There's nothing wrong with that, okay? Sometimes, however, it's it's a little tedious if you're trying to snap to edges and you want to include everything. So there is a command that Carlson has called shrink wrap polylines. It lets you select some data and it will create a boundary for you. And that, if you look on the draw menu, because you want to draw it, you're going to create it, and that's shrink wrap entities. Now there's another command right above it called boundary polyline. Don't use that one. That's a different command. What a boundary polyline does, and I'll show you just with a couple of examples. If I draw a circle, and then let's draw a rectangle, and then maybe we'll put a line through something right here. All right. So when we draw a boundary polyline, it's not the boundary around the outside of things. But if I click in here, for instance, or in here, let me change that layer so you can see that. So what that does, boundary is from the inside out, whereas shrink wrap goes from the outside in. So if I select, if I do that draw boundary polyline, it's just like doing a hatch command. So if I click over here, it's going to find the boundary that encloses the point that I picked, okay? So that can be a useful function for other tasks, just not for what we're doing. Whereas if we use a shrink wrap polyline, I'm going to go and change this circle into a polyline so it recognizes it. Now, if I choose draw shrink wrap, I'm going to allow it to either go across gaps or use bounded line work only. You'll see the difference here. And let's put that, well, let's see, surf boundaries. I know topo boundary. We'll make it a 2D. We'll say, okay, and I'm just going to select all of these items. And topo boundary is red and half. So where did it go? Oh, that was one. So if I go across gaps and I select all this data, then it's going to make this file, this line, it goes all the way around it, but it has to jump up here and grab the end of that line and come back down and then go around the outside. Go down here, grab that point, go up to the next point, come around. All right, if I do, now that would be, if like in the case of all of these, we're going to say go across the gaps so it doesn't try to jump inside. If I do, on the other hand, a case of bounded line work only, and I say, okay. Now you're going to see how it only comes around the outside edges, whereas this one, it's confusing because it's the same color. Let's make that also green. So it found everything and then drew an outlining boundary around it. So another good use of that command would be something like if you're doing phasing and you've got certain boundaries drawn around certain parts of your work and you wanted to calculate, say, the area within all of that particularly different shaped areas, you can do that and then select that drawn boundary and look at its properties and it will give you an area in square feet in this case, things like that, okay? So what we would want to do in the terms of our data, if we want that to go all the way around it, is we're going to draw shrink wrap boundaries and we're going to let it go across gaps this time so it can go and jump the gap across there. Now there's one other thing you need to look at is right here, this perimeter reduction. If you say none and then say, okay, let's grab our data. Here's what happens. It doesn't reduce, it's what they call the perimeter reduction. It doesn't reduce it any. It takes the outermost everything, and that's exactly the boundary that you had on the surface that you built that had all those long skinny triangles down here at the bottom and over here on the left. Okay, that's with no reduction. If I select that and delete it, and let's repeat that command, and this time let's change it from none to high. And we'll say, okay, now we'll grab everything here and select it around there and notice the difference. So it tightened it up, but in some cases it tightened it up a little too much, right? I got, things are just like right in here, for instance. I don't need it to jump down, come back out, jump down, come back out, jump down, come back out. So I might legitimately want to do something like this. I'll select my polyline and I'll just start, I'll reduce some of these inner pointing lines. And I'll say maybe, that's more like what I want. Maybe take those two out. Okay, so now, and you can do that and work your way around it, but that gets a little tedious too. So if we do that again and look at what's happening with these other settings, instead of high, none did no reduction, high did a little bit too much, medium or low, let's look at low and see how that works. And I'll say, okay, that's a much smoother looking job down here. You might straighten out some of those edges a little bit or not. And you could also, add some things in here, or you could even just select that, convert that to an arc. It maybe, tighten it up like so. Just make some slight differences. So you can pre-draw this boundary with that shrink wrap command, and then use that when you run the command to select your inclusion perimeters. Now, there's one other thing that you can do, and like we have some building perimeters out here called V building outline that we can select for exclusions. But even if you don't have any exclusions, we just want the inclusions. We can go straight to surface, triangulate and contour, and uncheck use inclusion exclusion areas. And this command will create the shrink wrap perimeter reduction. It will do that shrink wrap for you. If we had no reduction, that allows all those triangles. If we pull that down and choose one of these others, let's say put it to low like you had before, say okay, selecting entities, and it says the points and the break lines to triangulate. So we'll just grab the data. Oh, one thing before we do that. We'll repeat the command. One of the things I always like to do is if I'm going to use this command to create those for me, I'm going to look at the setup button and I want to draw it. I want to see it so I can make sure it's what I expect. I'll put it in 2D and I'll put it on that same layer. Now I'll say, okay, yes, overwrite. And now you see it created the boundary. So that's the shrink wrap boundary that the command used. I got these little ignorable errors. I'll press escape. I'll now, one last time, go back and view this surface. Come on. All right, so that was my from break lines with boundaries. Now you can see it has no longer included all those long skinny triangles in these areas. There's still a couple like right in there that I might want it to trim out. But the other thing you can do is if you're not working up in there, you don't need to worry about it. Even if they're out there, they're just not going to be in the way. Okay. So again, now you can see you've got a nice legitimate edges on your road. You've got these nicely defined curbs. Now, one thing that if you might want to look at right in here is if you lay this back and zoom in, you might notice, see how that curb lays back at almost like a 45-degree angle? That's because in truth, it is a wedge curb out there, so it is actually shaped that way. But sometimes you'll see people will give you data. They'll only collect the face of the curb and the back of the curb because to them, they're saying, well, the front top of the curb is just vertically over top of the face of the curb. Okay. And so they don't bother to give you that line. But sometimes, and if you need to model that, then you're going to want to make a few changes on what you're doing. So I'm going to show you how real quickly to do that with a particular command called a 3D offset. So I'm going to select a couple of these curbs here. And I'm going to do that by view, show hide by selection. I'm going to hide, or I'm going to isolate by selection rather. And I'll pick this line, this line, this line, and this line. All right, so now I've got this. If I look at that from my drawing viewer, you can see how those lean back at an angle. Okay. Now I need to put the vertical face of the curb in, remember, to get the front, if that were a curb. It's not, but I'm going to show you if you have to do something like that. So what I need to do is I need to select this line here, down here at the face. That goes all the way around. I need to select this line, which goes all the way around. And I need to create a corresponding line for the top of the curb that is essentially straight over top of this line. But remember, it can't be vertical. Okay, so I have to lean it back just a little bit. Well, how do you do that? Well, if you're going to, we're going to offset that line. And we need to offset. And remember, the AutoCAD offset command can only do that in 2D. It can only take an offset of a planar object. So we're going to need a 3D offset that Carlson is going to give us. And we're going to find that on the edit menu, and it has 3D polyline utilities. And right there, it says offset 3D polyline. So if we choose that, I've got all kinds of different methods. I can offset from wherever that line is to hit a surface. So if I've drawn the outside edges of a building pad, for instance, and I want to create the line that would be wherever it offsets down to a surface at a given slope, that would be the choice I would use. But what I want to look for is interval, because I want to go a certain amount horizontally and a certain amount vertically. So I'm going to choose that by interval, and I'm going to say, okay. And I'm going to now answer my prompts. Down at the bottom, I've got vertical and horizontal offsets. So my horizontal offset amount, remember, I need to just make it a little bit back from the actual point of verticality. So I'm going to make that say 0.02. Let's say just 200ths. Okay. I'll hit enter. And now how much for a vertical offset? And again, you can put this in by percent, by degree, by ratio, vertical offset amount. If it's a half-foot curb, it's 0.5. I'll hit enter for that. Select a polyline to offset. I'm going to select this polyline. All right, and now it wants to know which side you want to offset that to. Well, since back here's the back of my curb, I'm going to lean this back. So I don't want to put it out here in the roadside. I want to put it back here on the curb side. So now I've done that. I'll do the same thing over here. Okay, and I'll zoom in down here. I'll select these two lines that I just made. And let's change their color to be green. So now you can see we've got two different things. I'll look at this now. Maybe let's do a quick profile from screen entities. And let's go from here across to here. And now you can see how it goes to that edge. Let's zoom way in. It comes up here and gets to that face edge at the bottom right there. And then it climbs up to the top of that green line. And then it comes back to where it crosses the original back curve. So now instead of that going like this, if I show that the way it was originally, where we did not have the green line, so we had this line and, oops, no, I need to, well, if we didn't have that green line in there, you would see that triangular looking shape. If you just erase these for a second. But now then, if I did my quick profile going across, see the different shape, it's triangular, it's slanted down. Whereas if when I use it, I put those things back. So now when I go across it, I can see it's now got those near vertical faces, okay? And it makes it flat across the top. So now what does that look like then when we build that as a surface? Let's just make this a little bitty surface. I'm going to triangulate and contour, and I'll just call this one, this little surface, I'm going to call parking island. Maybe it's a trigger with that. Okay, so we'll call it PK Island, except it says OK Island, regardless. And now I'll just select my entities here. It's going to draw a little inclusion to show me where it was. That's fine. And if I look at that surface, now you're going to be able to see, of course, it it did this up in here, this little edge up in here, because it went from just a dead end edge to jumped across. I would need to have, some other data in there or put in a break line. But what I'm wanting to show you is now this nice vertical edge of that surface. Okay, and then you can compare that to, if I go to my model tab and add a surface, apparently it doesn't. I thought maybe that would help trigger it out of that mode. So if I add to that my full surface, there it's a different surface, and you can see how it compares. Now notice the curb right in here from that one. I'm going to open up my two surfaces. I'm going to toggle this one on and off. So there it is without the vertical lines. And here it is with the vertical lines. So you see the difference? And so it's just little tricks like that, little things that you're going to be doing that you need to do with this to help you, um, you know, supplement your data, do whatever you need to do to make these become what you intend. And so use those 3D views, and I'm going to put everything back to where it was. All right, so that's how you model your data, whether you let it create the boundary or you draw your boundary or you ignore it and you just live with those triangles. It doesn't really matter unless you're looking for numbers and things out in there for volumes and such. You want to make sure you do that correctly. All right, so that is sort of the overview on building your data. And remember, when you do that, let's turn on, let's go to my surface and let's um, draw surface. Let's draw the triangular mesh. Well, here we go, finally. So if I draw the triangles from this mesh, it's going to show you all the triangles that it created as part of that file. There they are. Now, if you look at where they are, I'm going to select similar. And I'll change their draw order so you can see other things on top. So now you can see everywhere those triangles hit a point is where it hit a point along those features. So right here, this particular feature, you see it, see where the vertices are there? So we can only hit up to the vertex. And when it hits right in here at this point, there's a CAD point right in there. So I could have taken that white 3D break line and added vertices in there, even though it's a straight shot. And so I would get, additional triangles in the middle there as well. That's called densification. In this case, not really all that necessary. And you see how here this one was densified a little bit. So you got smaller triangles in there. Maybe this one could have, it depends on how many vertices that you have along there. Each point is going to be used for part of a triangle. So you got some that this point looked around and saw that point, that point, that point, that point, that point. And so as it's doing it, it's forming those triangles. And they can be legitimate, but sometimes they're not. And sometimes you have to add some data to it. Now, here's how you do. Well, first of all, another great command is edit erase by layer, so you don't have to isolate things. You can select layers from the screen. I'm going to just select one of those triangles. It identified the layer. You can get multiple layers. And I'll say okay. And now it's going to clear all those out for me. So I don't need them in my drawing. Okay. So now they're out. But one way that you can densify a polyline. Let's zoom down here and look at this one right here. So if I needed additional points in there, I can either manually go through and do it, or I could, let me see about how, I'm from here to here, 2.5 feet. All right, so we'll say 3 feet. If you go to the edit menu polyline utilities and you want to densify polyline vertices, then I'm going to add to this polyline an interval. Let's go every 3 feet. Okay, so it added 12 points to that polyline. I select it now. And now you can see it's got additional vertex points that it can use for additional triangles. So it won't have those triangles restricted to just this point and just this point. It'll make triangles to each of these points as well. Okay. So that's one way to do that. Now, what happens when you add all these vertex points into all of your data is you get a lot of additional things in your file. You might not want to do that for everything. Okay, so there's another little trick. When you are running the triangulate and contour command, if you find you do need to densify those to get your triangles a little smoother and a little less big giant triangles, you have down below here in the bottom part or a switch that you say you can densify your polylines and you can give it a certain interval. So every 10 feet, I want to point, or every 3 feet, I want to point, whatever you want to do. And then it would take care of adding those points into those lines, but it doesn't put it in the drawing. It only does it in memory, builds the triangles from that, and then it discards them. So that's a nice little switch to have in part of this command. Okay. Everybody follow that pretty well? All right, any questions on this part of about building surfaces? Oh, one last thing we do want to check on is to draw the contours. So I'm going to turn on all my layers again, and this time I'm going to freeze just those white layers. And we're going to draw the contours from our surface file. And remember, when you do this command, triangulate and contour, as part of creating the file, you can also tell it to draw the contours and you fill all this out, okay, as well. But you can also, if you don't want to do that and clutter things up, you can, after the fact, once you have the file, you go to Surface menu and you're going to contour from a tin file. So we run that command, it's going to ask us for the tin file, which is why it's staggering here. So here's the tin file I want to contour. So I'll open that. And now it's going to bring up a dialog box that is just like before, with the exception it no longer has that selection tab. And on the triangulate tab, it doesn't have everything that it had on it, but I don't really need anything over here. But it lets you control, whether you erase previous or not. And you can say use inclusion or exclusion if you only want to look at it in certain areas. So even though the surface goes all the way out to our red outline, I could say draw a smaller inclusion area that I want to draw the triangles within, and it would read that, create the contours, and then trim them off at that new boundary. But I'm not going to do that. It's only going to go out to as far as the surface is defined. It's not going to fill in these triangles again because it's not triangulating. Okay. So I don't need to do any of that. I'm just reading the surface. I'm going to create the contours. So I'm going to go to my contour tab now and turn on that I want to draw the contours. And notice you can contour by an interval, or you can contour a specific elevation. So maybe you're doing a flood study and you want to say everything at this level. You just want to see that one set of contours at that one elevation. So back to contour by interval, and we got contour layers that we can put here. I'm just going to call this one CTR-INT. That's contour intermediate. And I'm going to contour interval of 1, just like I had before. And I'm going to draw the index contours, and I'm going to call that one contour X for index. Okay. And it's going to be 5. Notice if you change these numbers, it will update down below. If I go to 5, that should become 25. You see, I'll go to 1, and it goes to 5 for my index ones. Now, once you've done that, you're going to draw the contours. There's a real temptation to turn on this smoothing so it smooths out the lines, and you can control how much smoothing, and it shows you a little preview. The danger you run with that is that you could actually have, if your contours are real tight, you could have the smoothing make a contour cross over in a neighbor contour. But beyond that, more than that, one of the things that I rarely do contour smoothing because, yeah, even though it looks prettier on the paper when you print it, it's not really reflective of the surface because all it's doing is doing a smoothing operation on the drawn polylines. It's not changing the surface whatsoever. It's just, um, it's just putting the surface is still what the surface was. Okay. So we're going to do a little example here in a minute to show you the difference of how you can create that separately. So I'm going to say no smoothing, and I'll go over here to my labels. I'm going to label this on CTR-IDX, same layer that I had. We'll put this here as well. Standard style, height, decimals. Okay, now what I want to do, I don't want to break my contour at the label, but I'm going to hide the drawing under the label. That's this down here. So it's going to create a wipeout and put it behind it so it looks like it's broken. I'm going to label my index contours only. I'll align the text with the contours. I'll put it up at their proper elevation. And now, how many contours do you want? Well, I'll put these, say, let's say every 200 feet. And I'll say, okay. All right, so it's going to go through and contour everything. It's giving you a little progress report down on the command line. And then when it's finished, you'll see all the contours show up. All right, so there they are. So now your layers, if you don't specify colors, I think what it does is it creates the index contours as red and the the intermediates as white. So you can have those layers predefined in certain line styles and colors and all that work. So let's compare our drawn contours with the contours that they provided, the green ones. So if I zoom in down here, I can see, wow, we followed them really closely in this area over here in the road, up in the road edges. That still looks really nice. There should be somewhere. So like right there's a little difference. So there's their contour line compared to our contour line here. So, there could be some reason why that's different there. It's not enough to make me chase it down. I would look down here, see there's all of our contours right down the face of that retaining wall, which they didn't provide any contours there. They just broke them out. But as you see, like right here's another case where the green ones are the ones they used. So they may have smoothed that contour a little bit, whereas ours, these white ones, are a little bit different. But for the most part, we're pretty close. You might find something that you might decide to say, fix something like that. I just removed that little vertex out of here, but that really doesn't change the underlying surface. So, you could do something like that to fix these contours to make them match. I wouldn't go to that effort. I would just compare them to see. And here's what else I would not do is if I look at this and do my comparison and I say, well, everything looks okay to me, it all looks legitimate. Then since they provided the contours, and actually when they do that, they guarantee those contours to be within national map accuracy standards. So there's no real reason for me to draw an additional set of contours. I'll just use theirs when it comes time to plot with. Okay. So I'm going to erase my contours, oh, let me see, one thing, there's our labels, okay? On their index contours, you can see them there. And so one thing you can do with those labels under our surface menu, and we look at our contour utilities, is you can move the label along the contour as long as you don't break it. If you hide, you're okay. So if I select that command, I choose that text and I move it, notice it just walks right down that contour line. So I don't have to move it from here to there and then rotate it. I'll just put it wherever it needs to go. Let's say I put it over here instead, and then say, right here's one sort of in an awkward spot. Maybe I'll move it back to here. Okay, so you get the idea, and you do that for however many things you need to do. All right, so when you're done, all right, here's another case where this is probably in an awkward spot. I would rather have it like right in there. Okay. Same thing right there with that one. I would, put them over here. So a couple of nice little utilities you've got for that. Now let's go ahead and clean out our contours. Oh, by the way, there's another spot where you can see how ours are really, uh, they really fit. We've modeled that little sluice area, this little ditch area up here, and it fits theirs very nicely. Okay. So I'm going to go to erase by layer again. So edit, erase by layer, or pick it from your layers toolbar. And this time, notice it keeps the last time you ran the command, it keeps what was in there. So I'm going to hit the clear button to clear that out. I don't need to look for that layer. It's nothing on it. I'm going to select my layers from the screen. I'll select one of my contour lines on the intermediate and on the index. I'm through selecting to identify the layers. You see they're both there. I'll say okay. And we're back where we started. And so I would use their contours to do my plotting. And I'm satisfied that I built the surface the way I want to build it. Okay. And I could even at this point get rid of that boundary I no longer need it. All right. So that should give you a good immersion into that process. And again, that's going to follow a lot of these things that you looked at in here before. Okay. And this particular color range, notice I changed the colors that red were low, blues were medium, and greens were high. So I like the blues to be my low that looks like water. Mediums I'll take as green, and my highs I'll take either as a white or a light gray. It look like snow on the mountaintops, that sort of thing. All right. And you can see from this one, we actually use the exclusion areas for those building areas. All right. So now let's take a look at this final exercise and see about putting a lot of these tools together. It's a simple enough exercise. Oh, there's one other thing I want to show you before we get off to this. In terms of making some let's say refinements to your modeling information. So let's take a peek at, I'm going to go over here and, oh, one last thing, Brian Mayfield, since you are in Southwest Pennsylvania, I told you that you were going to recognize where this is. If you look at, I'm going to go to my settings and I'm going to look at my drawing setup, and I'm going to make sure that I am using this predefined, this Pennsylvania South projection. That's what I want to be in, is I'm in the South zone of Pennsylvania. And once that's defined, as long as my coordinates are legitimate there, I'm going to switch over to my GIS module for a second, and I'm going to bring in from the images menu, I'm just going to place a Google Earth image. And I'm going to load that command up. It's waiting to ask me for a file name. Show you in a minute. Keep hoping I can find something to make that process go faster. I can't seem to do it. And if I restart Windows, it works okay until the first couple of times, and then it goes into this slug mode again.
I'm actually in southeast Pennsylvania, so I may not recognize it.
What's that?
I'm actually in southeast Pennsylvania, so I might not recognize this.
Yeah, but you will once I show you this. Once I show you this and I tell you where it is. Oh man, come on. There we go, finally. All right, so it's going to ask me for an output file. This is going to be a little image file. This is going to be called my site location. I'll just make it a PNG. I'm going to pick from the screen where I want it to go. And so I'm going to go, say, from right in here up to here. So it's going to go out to Google Earth and it's going to find, and you'll see if it doesn't have high resolution available, it'll be grayed out. But I've got high resolution. I'll use an aerial image, or I can use a hybrid where it's going to label the roads, for instance. And I'll say, okay, now watch what happens. Now, obviously, you need to be connected to the internet for this to work, of course, because it's going to Google Earth and getting the imagery from that. And there it is. And you still may not recognize it till I tell you what this is. If you ever drive the Pennsylvania Turnpike, you know where Breezewood is, right? And this is the Breezewood exit, comes off here and comes around the corner, and then it comes down here. And this, you see that's your I-70 ramp that comes off of, up here should be US 30 or whatever that route is up there. There it is. So US 30 comes down below. Up here's your truck stop area in this corner. And so that comes down, there's the big interchange. There's a light right in here and there's a light right in here. And this is the one where sometimes when I'm driving down here and I need to go to 70, sometimes I'll get in this wrong, the wrong turn, and I'll turn a little too quickly. I mean, I've learned
I
that.
actually do recognize this. I've been there.
Yeah,
Driven by that.
figured you had. So they did this for either PennDOT or I guess the Turnpike Commission maybe, that they did this work for. So anyway, that's that. Now, one thing to remind you of, or to tell you, if you have the GIS module and you can bring those images in, if you do that from Google, if you zoom in here and you see how those curves don't exactly fit, well, that's because Google doesn't have all that accurate data. It's accurate enough to give you the imagery, but it doesn't give you much there. There is something that you can do as well if that's the only source. Now, normally when you add aerials to your data, you're going to get good ortho-rectified data from your state sources like POSDA, where you've got good GIS data that's coordinate exact. But I'm going to switch to another module here called my CADNet. And it has a command called, under my raster image, called rubber sheet. And I can do that by showing it some point. So it's going to actually warp the image. So I'm going to pick, where it's going to go. So I need this image to go from this back part of this corner here to that corner. I'm going over here to this other corner. You can hardly see the crosshairs. So that's now to that corner. Let's see, to give it another something that I can help see. Here's some inlets. So if I go from here to here, and let's come down here. I've got one from there to there. And let's just get a couple more here. I'm going to go from here. I can find where the crossing. My cursor, there it is. From there to there. And then finally, let's get one more down here. From there to there. We're over here. Let's go from there to there. All right, so now I've given it a bunch of points. I'm going to hit enter. Now watch what happens when it morphs the image. And now when we look at it up here, see how those snap to where they're supposed to be? And the more control points you have that you can give it, the better it's going to fit. So that's helped it to fit a lot nicer than it does just straight out of Google. But that's you have to have the CADNet module to be able to do that. You have to have the GIS module to add Google imagery. There's that retaining wall that we looked at. Okay, so we got a pretty nice and decent fit with their image data. And this is just nothing but, cool stuff to help you if you need it. All right. So let's take another real quick exercise with a new file. I'm going to close this. I'll go back to my start tab and I'm going to make a new file, new drawing. I'll use a template and I'll just use the old survey civil drawing template. And I want to give you a little food for thought in terms of, see, let's set in our fundamentals class. And we're going to call this park lot example. Horizontal scale, let's say 30 again. One. Doesn't matter the coordinate zone, I'll just say none. We'll say next, and we'll say exit. And okay, so we're good to go here. We're just out in blank space. Now what I want to do is I'm going to do a ZC to zoom center, 5,000, 5,000. So that's now the center of my zoom. And it wants to know a height. I'm going to say 500 for that height, or the height is not elevation up in the air, it's the height of the view screen. So if I'm about in the middle, you see down here on the status line, you're around 5,000, 5,000. And if I go from down here at the bottom, my X comma Y, that's 4,600. I go up here toward the top and that's 5,300. So 700, 500, whatever that height is. So that's about, where I am in space. Now, I want you to draw a building. We're going to draw a 2D polyline. And we're going to put it on C-building. And I'm going to draw right here. And I'm going to say, make that building, let's make it 100 feet. I don't need a coordinate file. And if I go, say, 100 feet to the coordinate file, all right, we'll just call it junk. I don't know why it's asking for a coordinate file. What is going on? Draw 2D polyline. D for distance. That would be why. Oh, I was, it was reading my 100 as a coordinate point number. That's why it kept asking me for the file. So I'm going 100 feet. At the cursor direction. And I'll quit that regard. So there's 100 foot. I'm going to make this into a building. I'll make that 100 by 50. So I'm going to say go D for distance. Again, by the cursor, because I was lined up there, that's squared. And now I'm going to Q for quit the distance, and I'll just hit enter to finish. I've got two edges of a building. I'm going to go back to my survey tools, and on the survey menu, I have a cool little command called four-sided building. That will complete that for me. All right, so I got a building there. Now, I'm going to make a parking lot that's going to be draw 2D poly. I'm going to put that on see parking. Let's call it back of curb. All right, so I'm going to go from here. Just put it out to here. And I'm going to go that direction and hover here, and I'm going to come to this direction. Get right there on that corner, and then come back to here, and then close. And now I'm going to move that off the edge there a little bit by selecting it and choose. Where's my move command? Right there. I'm going to go from there, and I'm going to go in this direction 10 feet. And of course, it went the wrong way. Let's move, say, from there at -10, that was 0. All right, so I now have a building. I'm going to set that elevation to be, I'm going to give it an elevation of, say, 123.45 feet, 123.45. Right, so it has a flat elevation. Now I'm going to have this to be my parking lot, and it's going to be, let's say, 123 or so, something or other, but I'm going to establish it. Let's say I make that also 123.45. So let's just call it 122.5. So it's a little bit lower than the building, and it's flat, but I don't want it to be flat. I want it to have a slope. So I'm going to switch over to my civil module and give that a slope. And you don't have to worry about doing this if you don't have civil. But I just want to show you what's going on. So I'm going to go to my polyline elevation editor. I'm going to select this. And I want to go from, I see there's my first coordinate, and it goes in that direction, sort of clockwise. So if I go back here to my first coordinate, that's going to be set. Number 4 is also going to be set. Number 5 is redundant. It's also the same. So, but 2 and 3, I need to set 2. So if I sit on 1 and I want to set the elevation of 2, I'm going to go down to 0.2, and I'm going to give that a downslope of 2%, -2. And then I'm going to go back. I'm going to sit on 4, and I want to set this point from number 4. So I'm going to sit over here on 4, and I'm going to reverse the direction of my line so that 2 now feeds 3. So I'll sit on 3 and I'm going to give that one a slope of -5. So it's going to go 5% down. So now when I look at 1, which is here, it goes to 2, which is flat across, goes to 3. Oh, it's the wrong slope. That's slope in. It's 5. There we go. That's down. And now 4, I want to set from 5, or 1 rather. So now there's 2, and it's going to be at -2%, -2. All right, so what do we got? I've got 122.5 at 1. Let's reverse it again. So at 1, it's 122.5. At 2, it's 122.5. It's flat. It goes down to 3 by 5%. Then it climbs back up to 4 at 2.6%, and then closes back on itself at 2%. Okay, so that's what I want. I'll say okay. And so now I can verify that by my drawing inspector, and let's turn on my polyline data. So if I look at this polyline, I see it has a slope of 0% on that segment. I've got a 2% slope on that segment. I've got a, let me also turn on my polyline direction. Yeah. And I've got a -5% slope there, a 2.63%, and then it climbs back up to 2. So I'm dropping from this corner. That's the same as my building. I'm dropping down 2% here, and I'm going to this corner and I'm dropping down 5% here. So they're slightly different corners. Now watch what happens when I triangulate and contour this. We're just going to call it PKLOT. Oh, crap. What is it? I did the wrong command. So if I no, I do want to draw the contours. There we go. Better make my contour intervals 0.5. All right, so I will triangulate and contour. Nothing there. I will say okay. All right, that's O. So PKLOT. Say okay. And now I'm going to select just those items. And here's now what my contours are going to look like. Okay. My index contour is going to be this red one. And then you see what I've got here. And if I were to look at that surface, it's going to look like this. So I've got the building up there. You can see it's flat. And let's turn that off. But you see the triangles, it's got just this big giant triangle because there's just those points. That's all it has to be able to make those triangles. And that's why the triangles form. And if I do my contours, so, it slopes down a little bit from the building, and that's at the building's at one flat elevation. This edge is at a flat elevation. Okay, but So the contour is parallel to it, but these contours are going to come in here and cross it very sharply. So the um, so um, the temptation might be to do something like this. If you go to surface and contour from tin file, and we're going to choose that file, and we're going to draw the contours, and we're going to let's smooth the contours, and let's turn our smoothing way up here. And we'll say, okay. And he goes, oh, okay, that looks better, right? You know, that's what you're saying, but that's not really what your intent is. Your intent is to have this parking lot start, level up here at the back, and then it goes down faster to this corner than it does down to this corner, but it's smooth, but it should be nicely warped. Okay. So one of the things that you can do, I'm going to erase those contours now, is you can densify the data. And if we do that, I'm going to go ahead and draw this in so you can see it. So if I say densify my points, I'll select this guy. And let's go, so that's 100 feet. So let's go every 5 feet. And so now it's added all those points. So now if I triangulate and contour again, and let's turn the smoothing back off, and we'll say, okay. Now you see they're not triangular looking like that. And if I look at those triangles, when I look at my surface, oh, did I miss something here? Sure did. Let's make sure we save that file again. Yes. Okay. So now one more time. I will erase my previous. There we go. So now when I triangulate and contour, it's still going to give me these better triangles because I don't have just that 2 triangles for that entire parking lot, but I still have some issues because it's still sort of jammed up. So now you can see it by densifying those points, it made those triangles, but it made some go across in the middle here and not, I need to sort of make an even type of distribution of point data to be able to get to that. So here's what I can do in a situation like that. And I'm going to go ahead and take those points back out of my densification. So I now have this point. Now what I'm going to do is I'm going to want to put a bunch of brake lines across this parking lot. Okay. And I'm going to use those to go edge to edge. So I'm going to draw a 3D parking lot. I will, or polyline. I'm not going to prompt. And I'm going to snap, making sure I'm just going to turn my nearest snap on. Just make sure I grab it. So I'm going to go from here to something that looks sort of like that. And I'm just going to do this sort of eyeball. Now you could, if you had the civil module, you can offset those things. You can draw them and just offset them every 5 feet and then um, drape them on that on those screen entities, which you don't have that in your survey tool set. Uh-oh. And then this one final one should do me nicely. Okay, now, if we look at this surface now, and I'm going to turn on a couple things to help me. I'm going to come down here and say densify the triangles every 5 feet, or densify the break lines every 5 feet, and I'll say okay. Yes to overwrite, and I'm going to do now. Look at the difference in the triangles. All right, so if I freeze now these break lines, now these, remember, I had no smoothing turned on. This is the result of having those densifications done. And if I look at that surface, you can see how it created all of those triangles. And so now it's a nice, smoothly and consistently, drops down 2% on one side, 5% on the other. And I did not have to turn on contour smoothing to make those contours look smooth. But I also didn't have this giant crease down the middle of my parking lot. So this could actually be a nice little way, for the draining my parking lot down to this corner. I have an inlet down here to get the water out. So those are some of the tricks you need to think about, some of the ways that you can enhance your data or refine your data to give it more points to triangulate to. Now, I did not add points here. I did not add points to my break line data. See, they still just have the endpoints. But when I was running the command triangulate and contour, I said to densify it. So it did it all in memory, and it made all of the triangles, therefore, show up as having used all of those points. You can see where the break lines go across, and every 5 feet it dropped a vertex point, and that's where the triangles fit. And it made a nice, smooth transition. And I'm not trying to trick myself by drawing contours and saying smooth your contours. Okay. So keep in mind when you do say, smooth your contours, all you're doing is changing the drawn polyline. You're not changing the surface. The surface still has that big fold right down the middle, that crease between those two triangles. And you need some way to actually change the triangles. Okay. So with that, we're going to close that off. And we're going to run through as much of this stuff as we can here. We're going to build a surface out of some point data. And it is going to be a little stockpile. And then we're going to cut a pad into it. And we may or may not have time to actually get into the road part of the design. So all of the steps are in there for you to follow on your own if we're later, but let's see what we can have happen, okay? So we are going to actually open a file, I borrow pit. So we're going to, if I can get back to where it starts, here it is. So we're going to open a file called example1.dwg, and we're going to see some points. All right, so we're going to open example1 DWG. Okay. And I don't care. As my projection, none of this matters anyway. It's set to Alabama, but it's not any data. Now, what I've got in this file is just a bunch of points. I've got point numbers, elevations, and descriptions. Okay, so there's nothing I can do much with that. Let's go to my text styles. So I've got a bunch of points, the descriptions of some that say B and some that say B dash toe. So I've got, the points around the outside, those are the toe of slope. Those are my points. So if I'm going to make a surface here, how do I need to do it? Remember, we want to have a perimeter drawn around it. Okay, so we can do that. Well, let's draw a shrink wrap entity. We'll go to draw, shrink wrap entities, and we'll just let it go across the gap. We're going to put it on a layer called topo-bdy is fine. We'll say, okay, I'm going to drag this across everything. And there's my boundary around my stockpile. Maybe it is, maybe it isn't. I'm going to take a look at it. Everything looks fine here. It goes through all the toe points. But then look over here. Look, it shouldn't have gone up to there because that's not on the toe, that's on the pile. So you could, say something like this, hover over that, remove that one. And then up in here, it goes the same thing. There's a couple of other spots in here. Looks like it behaved itself, all except for that one. Okay. So I'm going to erase that one. Let's do that command again, shrink wrap polylines. Let's put our reduction up a bit to medium. Say okay, do that same thing. And now let's see, here's a case where it pulled in up here. So I would take that, reduce that polyline. Okay, just make sure you're all around the toe, and you would have to come down here and find this one here as well, get rid of that one. So that's all something you can do as well. All right, and I think part of the exercise will show you how you can actually make a point group out of those B toe points and just draw a line, just draw through those. But now here's what you need to recognize, and what I want to point out. You've got points in your drawing, but you don't have a coordinate file open. Look up here at the top stripe. It says CRD none. So let's say I wanted to draw a polyline. I'm going to go to the draw menu, come down to polyline and go by nearest found. Notice it needs to know now a coordinate file to process. Well, I'm going to have to say new, and I'll call this one just SP for stockpile. All right. And so it's going to go here. I'm going to set this on that topo BDY again. And in my description match, this time I'm going to say, starting with anything, but include now TOE. So B-TOE. And if I say okay, select from the screen or by point number. So now I can select from the screen, maybe come around here and select all those and say enter. And so now it only looked at the toe points because I selected from the screen, and now it did not go up here to my B point, nor did it go to my B point over here. But it also did not close. I need a closed polyline, so I can simply select it, go to my properties and say, yes, it's closed. And I can use that for my inclusion perimeter. Now, again, because I selected those points from the screen, what happened? Did it go? It made me tell it a coordinate file, but if I list all my points, I see that points listed 0. I have no points in there still because it selected it from the screen. So it didn't even look in the coordinate file, even though it asked me for a file to tell it. So how would you get those points in your coordinate file if you wanted to? And the answer to that is on your points menu. Remember your coordinate file utilities, and you're going to update your coordinate file from the drawing. So I will take all of the descriptions. That's my asterisk. I will say okay. And it says select your entities. And the line above it says select Carlson, Land Development Desktop, Softdesk, Inroads, Eagle Point, Geotometer, Leica, or Microsurvey Points. So I'm just going to type ALL, enter, enter to finish. And now when I list my points, I see a bunch of B-toes and B. Okay. Another thing you could have done to create that boundary, instead of doing a shrink wrap, you could have noticed that, hey, this starts here. Let's see, the numbers look to be pretty much in sequence, starting with, oh, say 2000 right here, 2001, 2002, 2003 to 4, and as it goes all the way around to 2028 right here. So I could have just said, draw a polyline 2000-2028 and then C to close. I could have done it that way as well. Okay, because they just happen to be in order. They're not always going to be that way. Right. So that's all legitimate ways of making your surface. Now, one other thing to think about is we're going to do this, we're going to model this as a stockpile. And so it's going to be selecting this data and creating a little surface out of it. But if I want to say, calculate the volume of material in that stockpile, what else am I going to need? Not only the surface of the stockpile, but I need the surface of the ground underneath the stockpile, right? And I could either assume it to be just on a flat plane. It's not. If you look at all the toe shots, you see they have differing elevations. So I need to make one surface that is just edge across to edge with nothing else in between. Okay. And that's going to then give me my bottom of my stockpile. Then I'm going to also make a surface that includes everything, and that's going to be the top part of my stockpile. So let's go about that. Let's build the top part of our stockpile. We'll go to surface, triangulate, and contour. And we're going to write the triangulation file. I'll hit the select button. And notice my file dialog is not draggy right now. So let's knock wood on that one. So I'm going to call that SP for stockpile. Okay. I will use an inclusion and exclusion area, which will be that boundary that we just drew. Or we could let it figure it out for itself, but I'm going to do it. And I'm going to go to my contour tab. Let's go ahead and we'll draw the contours, and let's draw contour interval of, let's say, 1 foot. No smoothing. Labels, let's turn the labels on, and let's go every, say, 150 feet down here, except not 1150, let's say 150. Everything's good for that. Make sure my selection doesn't have any filtering going on, and I'll say okay. So now select the inclusion parameter. It says select entities, but the line above, select the inclusion. So I'm going to get my inclusion polyline. Now select the exclusion. I don't have any, so I just hit enter. And now select the things I want to triangulate. So I do that, off it goes, it builds my contour mapping and everything else. So I now have these points, and they happen to be on a layer called PNTS. So let's just freeze that layer and get rid of the points. Eventually we can, let's do a couple of things here. I see that. What am I in? Let's set our text heights, let's see, what's our text? Is 4. What is this set to? It's at a 50 scale, so that's probably right. Let me change that to 20. That to 1. Okay. MSLT scale should be on. All right, so that's good. So now I'm going to repeat that triangulate and contour command just so that I can get the text a little more reasonable. There we go. Now you see your labels. And remember, you can do that surface contour utilities move along the label, so you can move, say, this 400, to a little less problematic area. Okay, so, and that's just cosmetics. All right, so now we've got things are labeled, we've got contours drawn. Now, there may be some issues like right in here, and we're not going to spend the time to analyze it. But you see this point at 399.12 and this point at 397.74, and you see the contours. There's something that's pulling that contour up in this direction, and it's very possibly, some difference in the points values. But if you look at your surface, now that we've built it, there's my SP for stockpile. I'm going to turn that back on, and I look at that, and it's okay. I mean, there's that little, you see how that triangle edge made that go across here and pull the triangles up. Okay. So, and pull that contours up. So, there's ways you can fix things like that if you had more data. Again, it's a pile of rocks. We're not going to be all that worried about. But one of the things, if I switch, I'm viewing the surface instead of the drawing. So I can use this arrow now, and let's say if I want to swap a 10 edge. Now watch the contours. What happens when I double click that line? You see how that changes things fairly significantly. And let's see, let's pull that one back, and let's swap this one, and then maybe this one. So you see what's happening, and you can just chase yourself all over this thing trying to fix it. All right. So I'm going to exit. I'm not going to save those changes. I just want to show you that sometimes that's what we do to try to fix things like that, is we go in there and start swapping edges. And sometimes it's legitimate, often it's not. So just be aware of what has caused some of these results. Now I'm going to go back to my topo boundary layer. And I'm going to make that, say, cyan and a little heavier. Make sure we're viewing it. All right, so there's my boundary. There's my point. So I've got a surface, right? So viewing that surface, and I can spin it up and say, look up under its skirts and whatever else. I see that that's a surface, but how do I get the volume of that surface? How do I compute that volume? And remember, we said we need to have an underneath surface. So we need a surface that considers this outside boundary just going edge to edge. And maybe there's just using those B toe points, but not including all of these B points, just the B toe points. So I could do a couple of things. I could go around and freeze all the B points and do stuff like that, or I can draw a 3D polyline around the outside and just select that. So if I go to draw 3D polyline, and I'm going to not prompt, I'm going to let it find the points. And I'm going to say, okay. And now remember, it says pick a point or point number. So I can go from 2000 to 2028 because I found out that they go in order. So that's where they are. I'm now at 2028 and I'm going to close up to 2000. So C to close. And now that's done. And that layer is my 3D break line. And I'll show you that one. All right, so it's there, but it is now. And if I look at everything in 3D with my 3D drawing viewer instead of the surface, and if I uncheck ignore zero, well, can't really do that. But now you see that boundary is now drawn around the edges in 3D. The one thing I want you to look at is right up there in that corner. That corner has a little lift up on it. You see that right in there. So when we compute stuff there, you're going to see that one high point is going to give a little bit of volume difference. And it's just because of that little corner being turned up. We're not going to worry about fixing it right now. All right, so now I've got that. Now I could have, like I said, I drew that 3D polyline, but you can also do that draw, shrink wrap entities, go to cross gap, but this time instead of 2D, you could have made it a 3D. All right, now the reason I wanted to use this 3D polyline is so when I make this next surface, I don't have to fool around with these other points and turn them on and off and things like that. I'm just going to make the surface out of that boundary. So I'm going to say surface, triangulate and contour. And I'm going to change the file. So I'm going to hit the select button and I'm going to call this one SP-base. And this time I'm going to say erase previous contour entities. I'm going to pull that down and turn that off because I don't want it to get rid of my contours. I'll leave them on. If you accidentally do that sometime, you can always go back to the surface menu and say contour from tin file and recreate them. So don't be afraid of it, but no need to do that. So I'm going to say that's fine. I'm going to say okay. And now it says select the inclusion perimeter. There it is. Any exclusions? None. And now select the points and break lines you want to triangulate. I'm just going to select that 3D polyline and hit enter. It built a file. I'll look at that file. It's called SP base. And there it is. And it looks like that. It looks like this in terms of triangles. Now, what can you do? Remember, you've got these long edge-to-edge triangles, but you got these big flat areas in here, okay? So, and you've got things like this jigger-jagger on these contour lines, and that's because the triangles are long and skinny in this direction. And if we did something like swapping our 10 edges, you can, let's say go every other one. So you can sort of smooth things out like that and sort of, try to look at that and try to make those go away. But again, that's, you'll chase yourself all over your surface and trying to fix that. So there's no real way of doing that correctly. I'm going to say, no, I'm not going to save those changes. But what I want to do, what the heck is, oh, shoot. Now I've got to go back and fix it. So what did I do? Anybody? You see, I've got a contour line here and I've got a contour line here. And what happened was I threw the contour lines from the base surface as well because I forgot to check it and turn it off. So I'm gonna have to go back and now erase by layer. And I'll select one of my index and one of my intermediates. Get rid of that. And at this point now, I'm going to draw back my contours. Contour from tin file. I'll use the stockpile and leave everything like I had it and say, okay. And now they're back to where it was. I could move the label, for instance, say up to here, etc., etc. Right? This one. And that's probably okay. All right. So now I've got those contours back on, and I could, and remember when I looked at the surface of my base, I had all of these kind of goofy triangles that sort of, and this giant flat one in the middle. And honestly, that's okay, but to help chase that down, there's something else that you can do, just like we did on the parking lot. And if I take I'm going to isolate the layer of just that polyline. In fact, I don't need the points on any further. I'm going to say I'm going to freeze off the points layer. So I'm going to freeze by pick, and I'll pick the point itself. Okay, so they're now frozen. And now I could isolate this. In fact, I will. I'm going to isolate this layer now. And again, these are on the view menu. So now that's just the 3D polyline that's in my drawing. And I'm going to put a series of lines across here to sort of give myself some additional points, and I'm going to have it densify. So I'm going to actually do a little trick here. I'm switching to civil, and I'm going to draw a 2D polyline this time, and I'll pick the 3D break line surface, even though they're not 2D. And I'm going to just do this. I'm going to draw a line that sort of goes across my surface. And I'm going to now offset that multiple times. So I'm going to go to edit and just a standard offset, because remember, these are 2D. So let's do a multiple offset, and I'm going to go offset distance of, let's say, every 5 feet. How many repetitions? Let's say 25. I have no idea really. I'll select this object. I'll go in this direction. There it is. And I'll maybe do a couple of these. Let's just copy those up to, say, right in here. And I'm going to say, use this line to trim. I'll trim with the fence. Yeah, except it didn't. Like trim. The fence. Fence. There we go. Those are outside. well, these I can get rid of entirely. And I'll do the extend command and bring these others up again by fence. I'll go from there to there. And that should be it. And you could put another one in there if you want. Now, I'm going to use those, but now they're down at 0 elevation because you see that as I spin that up. So I'm going to actually elevate those to span across. So I'm going to go to, again, in Civil, my 3D data menu. I'm going to turn those 2Ds into 3Ds by screen entities. And I'll ignore zeros. No, let's not ignore zeros. I don't, well, yeah, that's fine. And let's put these on our 3D breakline layer. We'll say okay. It says select the polylines to convert. Well, I'm going to select everything, and then I'm going to type R to remove from my selection set and select that outside edge. All right, and now it says select the surface faces, lines, and polylines that you want to use. Well, that's the only one, is that outside edge. So now it converted 32 polylines from 2 intersections. And so now when I spin that up, you see what I've done is I've enabled those lines to lie across edge to edge at that elevation. And now when I triangulate that surface, oops, triangulate and contour, let's write the file. I'm going to select and choose that SP base again. I'm going to turn off draw contours. I will use the inclusions, ignore zeros. I'm going to densify every 5 feet. I'm going to say okay. And here's my inclusion, no exclusions, and now my data. Okay, it built it. I'm going to look at it. And now you're going to see some significant difference, you see. Now there's some folding along that outer edge right in there, and that's probably okay. Part of it's caused by that one bad point out there in the corner, all right? But you notice that the triangles are now smaller and more evenly distributed. And so they don't have that giant big flat spot in there. So that's a really probably a more legitimate surface. So I'm going to now just select across all of those and I'll just erase those. I don't need them anymore. I'll turn everything back on. Let's freeze my points layer again, which was down here for points. I'll just freeze it. Don't need them any further. I now have that. I've got a boundary. I've got my contours. I've got a surface. So let's calculate the volume in that stockpile. So again, volume calculations, again, it's a surface function. So I've got right here my surface menu, and I can choose volumes by triangulation. Now, notice that you can have a 1 triangulation surface volume, a 2 triangulation surface volume, or a 3 triangulation surface volume. And what that does is if you were to say 1 triangulation surface volume, what it would do is ask you to choose the surface. That's my stockpile. And now it wants to know, well, what are you going to use for a reference? Well, you can either use just a flat elevation if you know the average elevation around it, or you can use the 10 perimeter. And that does the very same thing that we just spent our time doing here, is that it creates a surface from the outside edge of that surface. Okay, so that's, you can let this happen in that fashion. All right, so it'll work that way. I'm going to cancel this for a minute and talk about another option under surface. It's actually called stockpile, pond, or pit volumes. And you can calculate your stockpile volume, but now this requires a couple of things. This requires you to have drawn the perimeter on a specific layer. So if I calculate the stockpile volume, says select the stockpile entities and perimeter. Well, that might do it. And you can use tonnage. Let's say it's limestone, 120 pounds per cubic foot. And let's just say, okay. Now to select a perimeter line, I think this is going, now see what it's doing here. That's what I'm going to show you, is that it's making a grid surface out of this data. We've already triangulated it. We've got more accurate data anyway, but this is a way, if you're doing stockpiles, you can just real quickly go through here and do these and let it come up with this. So I'll say that, you see it's calculated that. I'm going to put that on the screen and I'll go over here to the side and I'm going to put that down in that spot. And I'm going to go in here and edit this. And I'm going to say, this is my volume report by stock pile calc using grids. And then I'll go out here and say get this using grids. Get rid of some of that. It's too much. All right. So we're going to use that to compare some things with here in a minute. All right. So now, because we do have these two surfaces already made, let's go to, and it's going to give us a more accurate result. So we're going to go to surface volumes by triangulation, and let's do a 2 triangulation surface volume this time. And that's going to be, it's going to ask us for 2 files. Read the top stripe here. It says select the existing surface. The existing surface is my base. I'll open that. Comes right back and asks for another file. What's the final surface? Well, that's my SP, my stockpile. And select any inclusions or exclusions. I don't need to, it will go out to the existing edges. So I'm just going to hit enter and enter. And I'll do all this. Let's report tonnage and let's call it 120, same as we had the last time. And we'll say, okay, there's our report. Let's dump it on the screen and let's compare it to the other one. Let's just put it right here. Oh, Lordy. Here we go. So notice the numbers now. This one was our grid from the stockpile calc, and it tells us that we had 69.61 tons, or 104,000 cubic feet, or 3,870 cubic yards of material. Okay. Now over here, we just did 2 surfaces, and so it's going to give us the amount of cut and amount of fill. Now there's where you got that little bit of cut, 100, got 1 cubic yard of cut because of that little corner that's clipped up in that corner of the stockpile. But if we look at the fill numbers, we see that the area in fill is basically 25,000 square, or that's the area. But we come down here, we're going to look at the amount of cut and fill. I've got, where's my volume? It's up at the top, rather. So a little over a cubic yard in cut, but I've got 2,937 yards of fill, or 4,758 tons. Whereas compared to the other way, I've got what, 6269 tons. Right? So see, there's a considerable difference in those 2 calculations. And this one's done by grid. It's actually less accurate. This one, however, is done by triangulation, and those 2 surfaces are nice and accurate. So that's going to give us our better results. Okay, but on a site this small, we're talking, what is our total area? 25,000 square feet. Somewhere we had acres, like it's like half an acre, right? So that's not a very big site. So in that case, you're gonna notice more differences or a larger amount of difference is what you're gonna see. As opposed to if you're doing a 20-acre site, you're gonna see that those numbers are gonna agree fairly closely. All right, so that's how we're gonna calculate those volumes. Now, let's go ahead and take us our mid-afternoon break. We're gonna come back at a quarter till, and we're gonna cut in our little borrow area and, show you how we can merge those surfaces together and do those various things. All right. Anybody have any questions on any of this so far? I know it's moved pretty quickly, but everybody good? All right. Well, we'll save what we're doing. We'll come back and pick it up from here. I'll see everybody back at a quarter till.